Raven object and it will push it inside Raven's array. When that happens, I set time to next Raven back to 0 so it can start counting again from the beginning. I know I just said Raven a lot. Time to next Raven starts at 0. It increases by the amount of delta time, by the amount of milliseconds between each frame, which will be dependent on performance of your computer. However, since slower computers will take longer to serve the next frame, their delta time will be a higher number and it will move towards our target Raven interval in bigger steps. As a result, this code will be triggered at the exactly same time on slow and fast computers. This is one way how you can properly trigger periodic events in your projects using timestamps. This might be a bit too much to wrap your head around if you are a beginner. It's one of the reasons I don't always use timestamps in my animation tutorials, because I can't really explain all of this in every single video, but try to learn it if you can. If you still don't get it, don't worry. I will explain it in future projects again, so eventually it will start making more sense. Repetition and practice is the best way to learn, at least for me it is. I console log Ravens and I see nothing is happening, even though my animation loop is running. It seems that this if statement never evaluates the true, so the code inside is never triggered. Console log is great for debugging. I console log time to next Raven first. Oh, I can see its value is a none, not a number. Here's our problem. Why is it this value? It must be because we are adding delta time to it here. I console log delta time and I can see that the first initial value is also not a number. Delta time is calculated here on line 30, so now I console log timestamp. And this is the root of our problem, that cascaded all the way through my variables that use each other to calculate their values. When the animate loop starts, the very first timestamp is undefined because timestamp only gets created on the second loop here on line 39 when we call request animation frame. To fix that is easy. I just need to give timestamp a starting value on the first call of animate that starts my animation loop here. I will pass it timestamp of 0 as an argument. Awesome, that fixed it. And since I'm console logging Raven's array on line 36, I can see it adds new Raven object to the array every 500 milliseconds. I remove the console log. We have data for Ravens inside the array. We just need to cycle through that array, through every single Raven object, and call their update and draw methods, so that we can actually see movement on canvas. I declared my Ravens array here on line 10. Inside animation loop, I will use this syntax, which might be a bit unusual for you. Here I'm creating so-called array literal by just dropping square brackets like that. I'm creating a quick new array on the fly, and these 3 dots are so-called spread operator. Now I'm spreading my Ravens array inside this new quick array I just created. Spread operator allows us to spread iterable, such as this Ravens array, to be expanded into another array. Let's finish writing this line of code and I will explain why I'm doing that. Since we are dealing with an array, I can call built-in array for each method. I need to assign it a variable name for each object in this array, so we can use it as we iterate, as we cycle through it. I will call that variable, for example, object. So this object variable now represents each individual Raven object in Raven's array, and I can say for each Raven object in Raven's array, call their associated update method we wrote on line 20. So this line of code will cycle through the entire Ravens array and it will trigger update method on all of them. Since we are inside animation loop, this will happen over and over for each animation frame. I will do exactly the same thing for draw method from line 23. And we are updating and drawing our Ravens. Awesome. Now you might ask, why am I using this fancy syntax here, where I created a new array and I used the spread operator to expand my Ravens into that new array, just so that I can call update and draw on them. I could have just called it on the Ravens array directly without expanding it like this. The reason I did that is because when I create particle class in a minute, I can just spread my particles into the same array along with the Ravens. As long as my particle class will have update and draw methods to call, the code will work and I can call all my classes by just expanding more and more arrays in here. I can, for example, also have an array of enemies obstacles, power-ups, and other elements in my game. I can spread all of them into a single array and call their update and draw methods all at once. I will show you exactly what that looks like in a minute. I think it makes the code look clean and easy to read. What do you think? On line 34, I'm periodically adding new object into Raven's array. Right now it's an endlessly growing array of objects, and on lines 37 and 38 I'm iterating over all of them, even the ones that have moved off screen and are not visible anymore. Eventually this would build up and cause performance issues, so I need a way to remove the ones that have moved past the left edge of game area. Sometimes I use array splice method to do that. I used splice in many other tutorials before, but there might be a better way to do it. Using splice while cycling through the array removes objects from somewhere in the middle of the array, so then we have to write code to adjust the index to make sure neighbors of that object don't get skipped. Easier way to discard objects we don't need might be using built-in array filter method. We will just run through the array, call update and draw for each raven, and then we will filter out ravens that have moved past the left edge of screen. What does that look like in JavaScript? Let me show you. I create a new class property called marked for deletion, and initially I set it to false. In update method, I say if horizontal x coordinate of this particular raven object is less than 0 minus this.width, meaning it has moved all the way behind the left edge, I set its marked for deletion property to true. Inside animation loop, I take the variable that holds my ravens array from line 10 and I reassign it to a new array. That's why the initial declaration of ravens array needs to be a let variable, not const, because const variable cannot be reassigned. It will be the same array, but objects that have marked for deletion property set to true will be filtered out. Filter method creates a new array with all elements that passed the test implemented by provided function. So here I'm saying take ravens variable from line 10 and replace it with the same array, but I want that array to be filled only with objects for which this condition is true. Here we have a little bit of double negative, sorry. The test in my callback function wants marked for deletion value to be false. If marked for deletion is false, then this condition evaluates as true and this particular raven object will not be deleted. Again, and said very simply, take ravens array from line 10, delete everything in there and replace it with contents of the same ravens array, but only with those objects that have marked for deletion property set to false. Exclamation mark here means false. Since we are console login ravens array on line 42, I can check in browser console and I can see that number of objects in the array is between 3 and 6. It only contains ravens that are active and visible on screen. Perfect. I remove the console log. These ravens look a bit boring, just black rectangles. Let's use animated sprite sheets instead. On my class, I create a new property called this.image and I set it equal to new image. I set source on that new image as Raven PNG. Art for this episode was made by this amazing artist. Link to his website is in the video description. He also allowed me to share this particular sprite sheet completely for free with my students, so you can download it along with all other project files in the description. For more game art, check out his website and support him if you can. There aren't many good 2D artists like this, and he's one of my favorites. I try to buy his game art assets whenever I can. I will need a couple of helper properties here. This.spriteWidth is width of a single frame in my Ravens sprite sheet. In this case, 271 pixels. If you are using a different sprite sheet, take its width and divide it by the number of horizontal frames. Maybe it would be easier if you follow along with me using the same sprite sheet, and then when you understand the code and it's working for you, you can replace it. Sprite height is 194 pixels. On line 31, inside draw method, I call built-in draw image method. It expects between 3 and 9 arguments, depending on how much control you want over the image you are drawing. Minimum is 3 arguments, image you want to draw, so this.image from line 20, and x and y coordinates where to draw it. Now it's just simply taking the entire sprite sheet and drawing the whole thing at its original size. We can also give it optional width and height arguments, which will scale it. I need to make sure my brackets and commas are correct here. So now it's scaling the entire sprite sheet to fit inside 100 times 50 pixels. Let's do stroke rectangle here so we can see it better. We can also give it a total of 9 arguments. These additional 4 arguments will allow us to only crop portion of the image: source X, source Y, source width, and source height. So the longest version of draw image method takes 9 arguments: image we want to draw, X, Y width and height of area to crop out from the source image, X, Y width and height of where to place that cropped out image on destination canvas. Let's just crop out the first frame now. Source X and source Y is coordinates 0, 0. Source width is sprite width and source height is sprite height. You can see our ravens are a bit stretched. It's because these initial width and height values are completely disconnected from the actual dimensions and aspect ratio of our sprite sheet. I moved sprite width and sprite height up here so that we can use them to calculate values that come after. Width could be, for example, sprite width divided by 2, and height could be height divided by 2. This works, but now all our ravens are the same size, and as my friend Marcus says, multiplication is faster than division, so let's create a new property called size modifier, and it will be a random number between 0.4 and 1. Now, instead of dividing it by 2, I will multiply width and height by this random size modifier value, which will make the ravens be different sizes, while still preserving the aspect ratio, so no stretching. This dot frame is the number of frames in our sprite sheet counting from 0, so the initial value will be 0, this frame. This dot max frame could be 4 or 5, depending on how you reset it back to frame 0. Let's go with 4 maybe. I will adjust my frame reset check to this value in a minute. If this dot frame from line 25 is more than this dot max frame from line 26, set this dot frame to 0. Else, increase frame by 1. To actually reflect this value on canvas, I replace source X argument on line 37 with this dot frame times this dot sprite width. So it will go 0, 1, 2, 3, 4, 5, and back to 0. As frame variable cycles on line 32. All the ravens are flapping wings very fast and at the same interval. How do we speed up or slow down sprite animation, the speed at which the next frame is served, and how do we make sure it's consistent across all machines on old, slow computers and new powerful ones as well? We can do that by using delta time. We calculated delta time on line 43 inside animation loop. Delta time is the difference in milliseconds between last frame and current frame, and this value will differ based on power of your computer. Some computers can serve frames much faster than others. Since I already calculated this speed at which my machine can serve frames in my game, I will just pass delta time as an argument to my update method here on line 50. That way it will be available up here. Let's test it. I console log delta time. It won't be available until I pass delta time as an argument here as well. Now the values are coming through. I will need a couple of helper properties. Time since flap will be 0 at first. It will be growing by the amount of delta time until it reaches value in flap interval. Then it will trigger next frame of sprite sheet and reset back to 0. This dot time since flap plus equals the delta time. Remember that delta time is the amount of milliseconds between frames, so faster computers will have smaller numbers here, slower computers will have high delta time values. As a result, it will reach the target value at the same time on slow and fast computers, unifying animation speed across different devices. I say if this dot time since flap from line 27 is more than flap interval from line 28, only then run this code that handles cycling through frames. For this to work, every time this condition is met and if statement is entered, I also have to reset time since flap back to 0 so it can start counting again when to serve the next frame. Now I can change the value of flap interval and you can see it changes the speed at which we cycle through frames in our sprite sheet. 500 milliseconds per frame is very slow. 5 milliseconds per frame is fast, faster than my computer can handle, since we know my computer can handle the serve next frame every 16 milliseconds as maximum. I can also randomize flap interval so that each Raven animates at a slightly different rhythm. Random number between 100 and 200 feels too slow. How about a random number between 50 and 100? That feels better. Quick recap, we are calculating delta time, difference in milliseconds between last frame and current frame. The value of delta time will be different on slow and fast computers. To make sure we have consistent time in across different machines, we have time since flap variable that increases by the value of delta time per each frame until it reaches target value in the flap interval. Then it serves the next frame, resets back to 0, and starts counting again, preparing to serve the next frame. Ravens are flying in straight lines from right to left. I also created the direction Y property on line 21. It's a random number between -2.5 and +2.5, so some ravens will move up and some will move down in a negative or positive direction along vertical Y-axis based on this value. Inside update method I say this.y plus equals this.direction y. Now you can see some vertical movement. It's now a little bit harder to target them, making our game more difficult for players. One thing I don't like now is how they disappear behind the top and bottom edge. I want them to move all the way across the screen, and when they touch bottom or top edge of game area, I want them to kind of bounce and reverse their vertical movement to the opposite direction. I do that with an if statement. I say if this.y is less than 0, or if this.y is more than canvas height minus this.height, set their direction property from line 21 to its opposite value, this.direction y times -1. Now they just bounce when they reach edges of the game area. Let's draw score. I create a let variable called score and I assign it to 0 initially. I create a custom function called drawScore. Inside I set fill style to white. I want white numbers. I call built-in fill text method. Inside I will hardcode string score :space plus score variable we just declared, and I want it drawn on canvas at coordinates 50, 75 for example. Now I just call drawScore from inside my animation loop. Keep in mind, since we are drawing everything on the same canvas, sequence in which you call this will affect how our game is layered. I want score to be behind ravens, so first I draw score, then I draw ravens. It's very small, so let's set the global canvas font to 50 pixels impact. Now it's easier to read. I will play with it a bit. I can use canvas shadows here, but I can also just draw the same text again at slightly different coordinates, for example 55 and 80. The first layer will be black, the second layer will be white. In the game, we will have to click ravens before they disappear behind the left edge of screen. I create an event listener for click event. Callback function on event listener has the default access to this event object. I assign it variable name, for example E. It contains information about the click event that happened, for example its x and y coordinates in relation to viewport. If I console log e.x and e.y, I get coordinates of my click whenever I click somewhere in the game area. I promised we would do collision detection by color today. To do that, we first need to know what color is the pixel we are clicking on. I create a custom variable I call, for example, detect pixel color. It will be equal to built-in getImageData method. GetImageData simply scans area of canvas and returns an array-like object called uint8 clamped array. It's a simple data structure full of unassigned 8-bit integers. It's clamped, which means it can contain only integers, whole numbers between a certain value range, specifically between 0 and 255. Let's scan canvas and inspect what it gives us. GetImageData needs 4 arguments: x, y, width and height of area we want to scan. I want to scan just one pixel we click on with the mouse, so coordinates of this click event e.x, e.y, and width and height of scanned area will be just 1 pixel. We want pixel perfect precision here. Okay, let's just console log this variable to see in what format getImageData gives us the pixel color, to make sure we understand how it works. If you are getting an error at this point, keep watching, I will explain it and I will show you how to deal with it. Now, whenever I click somewhere on canvas, getImageData scans area of 1 pixel directly under the mouse click, and it gives us this image data object. This auto-generated image data object contains 3 main properties. Data property, which is an array, currently it has 4 numbers inside, and width and height of scanned area, in our case 1 pixel. The way color data is structured here is that each 4 elements in this data array represent 1 pixel. Specifically, it's red, green, blue, and alpha value. If you use CSS, you know that any color can be created by combining a certain amount of red, green, and blue. The only difference between CSS RGBA declaration and this is that in CSS, opacity is a value between 0 and 1. Here, opacity, alpha, is also a number between 0 and 255. 0 is transparent, 255 is fully visible. Here, for example, you can see I clicked and it gave us 0, 0, 0 for red, green, and blue, and 0 for alpha. It means we clicked somewhere in the empty area. Keep in mind that canvas is just the ravens and score. The rest is transparent. Rainbow colors you see are on the background and are applied to body element with CSS. We are calling getImageData on CTX variable, so it is just scanning that particular canvas element. It doesn't see anything else. Some of you might be getting error when you click on canvas and try to run getImageData on it. We are drawing sprite sheets, our Raven images, on canvas. In some browsers, you won't be able to call getImageData on the same canvas where you draw images. It will give you an error that says something like canvas was tainted by cross-origin data. If you are running your code locally, most likely you see that error. I'm using local server, so I'm not getting that error right now. It's a security measure related to cross-origin resource sharing. Apparently there could be viruses hidden in some images, and by scanning that image with getImageData, you could expose yourself to that virus. There are many ways to get around this problem and scan canvas without exposing yourself to any potential risks. In our case, it's simple. Let me show you. But first, I will assign a differently colored hitbox to each raven. So I want one canvas that has only these hitboxes and no ravens, because when I click it, I want to get color of that particular hitbox, not of the black raven. If I create a secondary canvas and I use it just to draw these hitboxes and no images, it won't give me tainted canvas error. I will explain more as we write it. In index.html, I create an additional canvas with an ID of collision canvas. In style CSS, I comment out rainbow background for a moment so that it's very clear what we are doing. The same as I set up the first canvas, I will also set up this new collision canvas. Be careful here, I always make mistakes and typos when assigning multiple canvases like this for some reason. I don't know why. Constant variable called collision canvas is document getElementById collision canvas. Collision CTX, which is context, is collision canvas.getContext2D. I also set collision canvas width and height. Just to check, I give it red background. Yes, it's covering the entire browser window, perfect. On my Raven class, I create a property called random colors. At the point where each raven is created, I want to roll the dice and randomly give it red, green, and blue color value. We know that color values can be in a range between 0 and 255, so red will be math.random times 255, like this. It will give us decimal points. I need only integers here, so I wrap it in math.floor. I do the same thing for green and blue. Now we have 3 random values in this array assigned to each raven object. I create one additional property called this.color, and here I concatenate RGBA color declaration using these values. Red is random colors index 0, green is index 1, and blue is index 2, plus closing bracket like this. To use this color, I declare fill rectangle on line 54 and I set fill style to this.color from line 37. Now each raven has a random red, green and blue color assigned when it's created by our class constructor, and we use these three values to create RGB color for its hitbox. Hitbox means collision detection area, and in our case, it's the colored rectangle around each raven. We can also do much more complex shapes and still get pixel perfect collision detection, but for purposes of this tutorial, rectangles are fine. I don't want to complicate things too much. This tutorial is to help you understand the technique. So now each raven has an array of 3 random values between 0 and 255, and these values are used to draw its hitbox. We will use these values kinda as a unique password for each raven. We click on canvas, get RGB value of that pixel we clicked on using getImageData method, and we compare them with this random colors property. If they all match, we know we click on this particular raven. This technique has one downside. There is a very small chance that there will be 2 identical colors generated next to each other, but since we do random number between 0 and 255 3 times, and we only have between 3 and 7 active ravens on the screen at any given time, the chances of that happening are astronomically low. If we have any math experts who can run the numbers, let me know in the comments. It will be 1 in millions, possibly billions. Now I told you what I want to do. What does that look like in JavaScript? Before we write collision code, there is one small thing: layers. I want big ravens to be up in front and small ravens to be behind, to create a sense of depth and correct the draw order in a 2D space. Right now, sometimes you see smaller ravens up front because they are drawn here on line 83 based on the order at which they were pushed into the array on line 78. I don't have to sort them for every animation frame, only every time I push new raven to the array. I want to sort out all objects in the array by size. I use built-in array sort method. Sort method will simply reorganize order of elements in the array, their indexes, based on provided check in a callback function. It will run through the array and compare every element against every other element and sort them in ascending or descending order. Ascending order is default. It will run over my ravens array and use these A and B variables for each object. I can choose many different properties to sort them by. Today I will choose width because I know ravens in the back will have smaller width than the ones up front. I'm just gonna return it like this, simple syntax, and I'm comparing width of every element in the array against the width of every other element in the same array. A minus B will sort my array in ascending order based on width, which is exactly what I want. I want small ones to be drawn first and larger ones to be drawn on top. You can read more about built-in JavaScript sort method online. We can see that it works. Large ravens are up front and smaller ones are behind. Perfect. As I said, I want to avoid tainted canvas error, so I need to make sure I have a separate canvas I can scan color from that doesn't have any images drawn on it. I take collision context variable I declared on line 6 and I draw my colored rectangles on that canvas instead, by adjusting code here on lines 54 and 55. Nice, that worked. I can see we are not clearing the old paint on that canvas, so on line 74 I call clear rectangle on collision context as well. Now we have 2 canvas elements. One has colored collision rectangle and the other has ravens and score drawn on it. On line 68, inside click event listener, instead of scanning my main game canvas for pixel data, I will scan just collision canvas instead. Now, when I click, it will ignore the black ravens and image data object will give me red, green, blue and alpha value of rectangle I clicked on. I will compare it with red, green, blue value inside random colors property on each raven to know which one was clicked on, and then I will set its marked for deletion property to true. There are many techniques you can use to compare 2 array-like objects against each other. Let's just keep it simple. When I click on one of these rectangles, I can see the values are inside this image data object on a property called data. Data is an array with red, green, blue and alpha value of pixel we clicked on. I create a variable to get hold of this array. Detect pixel color.data, which refers to this uint8 clamped array with 4 elements. There is also a way to check for collision detection between two objects based on opacity alpha value like this, but today we will do collision between point and shape, between mouse and ravens. I will ignore alpha value from now on and I will just focus on these three values, red, green, blue. So this PC, pixel color variable, holds this data array with 4 elements. I take my ravens array and I call for each on it. For each raven object in the array, I will check if its random colors property from line 36. If the first element in the array, index 0, is the same value as pixel we clicked on. At the same time, we also need the second and the third element to match. If random colors array on my raven matches exactly red, green and blue values on pixel we clicked on, we know we have a collision. Index 0 is red, index 1 is green, index 2 is blue. We are comparing the two. If they match, we have collision, so I will take that raven object and set its marked for deletion property to true, and I will increase score variable by 1. Awesome, it works. I can click on ravens and they disappear and increase my score. I can set opacity on collision canvas to 0, and I can enable rainbow background on body element. Collision detection still works correctly. Well done if you followed this far, you are doing great. What should we do next? How about we add explosion animation and sound effect whenever we click on a raven? I will just repeat the same pattern we did for raven class. I create an array called explosions. It will hold all active animated explosion objects. I will create a class to create a blueprint for these objects. Its constructor will expect 3 arguments, x, y and size, because position and size will come from the outside and will depend on the raven we clicked on. This .image will be new image. This .image src will be boom png. You can download the sprite sheet for free in the video description. Sprite width will be 200 pixels. Sprite height 179 pixels. This .size will be size we passed as an argument on line 61. Same for this .x and this .y. These values come from the outside. This .frame, active frame, will start from 0. This .sound will be new audio like this. This .sound src, source, and here as a source you can add any sound you like. For example, I will go to opengameart.org website. I click browse, sound effects, and I will search for Magic SFX, special effects. I will choose this pack of 4 sounds. I download it and I will use the one called Ice Blast. I will rename that file as a boom.wav and I will add it to my project folder. You can choose a different sound if you want. You can also have multiple sounds and play a random one here, it's up to you. In update method, same as we did before, I will use delta time to time my animation. We will have one variable to accumulate delta time values called, for example, time since last frame. It will start at 0. Then we need a second variable to define limit when the next frame triggers. I call it, for example, frame interval, and I set it to 200 milliseconds. I pass delta time as argument to update method. It will be coming directly from animation loop. I will show you in a minute. This time since last frame will be slowly increasing by the amount of delta time. If time since last frame is more than frame interval, 200 milliseconds, I increase this .frame from line 69 by 1. I also want to play the sound when we are on frame 0, when the explosion first appears. There are better ways to do that, but for today I will simply check if active frame of this explosion is 0, and I take this sound from line 70 and I call built-in play method on it. Explosions will also need draw method, which will draw the actual sprite sheet animation. we will pass draw image 9 arguments, same as we did with ravens. Image we want to draw, this.image from line 62, 4 values for area to crop out, single frame, so source x is this.frame times this.sprite width. Source y will be 0 because we only have one row of sprites. Source width will be sprite width from line 64, and source height will be sprite height from line 65. So now we told JavaScript what area we want to crop out. Now we need to give it x, y, width and height, where to place it on destination canvas, so this.x, this.y, and this.size for width and this.size for height. As this.frame variable increases here on line 79, because of this source x property, here we will show frames 0, 1, 2, 3 and 4. Now, where do we trigger this code to create and animate new explosion? The best place would be here, I think. This if statement detects collision by color. So when collision is detected, I take explosions array from line 59 and I push new explosion in there. This will trigger explosion class constructor on line 61. I can see it expects value for x and y coordinates and size, because I want explosion to depend on the size of the raven we clicked. So here we are cycling through ravens array, referring to individual ravens as object. I want to pass x, y and width of that raven as x, y and size arguments here. Okay, that should work. I can test it by console login explosions array from line 59. I can see as I click and hit ravens, explosions are being added. Perfect. I made sure my explosion class has update and draw method, same as my raven class. That's why here on line 123 I can simply just use spread operator and expand the entire explosions array into this array I'm creating on the fly, so that I can call update on all ravens and all explosions at the same time, like this. I do the same thing for draw method on line 124. I like this syntax, it looks clean. Down here I will also remove all the explosion objects from the array using built-in array filter method. I need to create a property called marked for deletion on my explosion class for this to work. As you can see, I'm repeating the same pattern we used for ravens. I hope that using the same structure like this helps you to understand and navigate in the code a bit better. Initially I set it to false. In update method I write an if statement. If this.frame from line 69 is more than 5, which means after all the frames of sprite sheet have been displayed one by one and explosion animation is complete, I set marked for deletion from line 74 to true. When I click on ravens, sound plays and explosion sprites are animated. We are making great progress, we just need to polish some details here. If I change frame interval on line 73 to 500, you can see it only affects the first frame. The rest of animation is playing really fast. Oh, it is because I need to reset time since last frame back to 0 every time, so it can count towards the next frame interval over and over to serve next frames. "500 milliseconds is too slow. Let's try 200. I want to align explosion animation better over the raven sprites. Let's move it a bit upwards by adjusting destination y argument in draw image method. I will make it relative to size, this.y minus this.size. This.size divided by 4? Yeah, I think this is aligned well now. Let's create game over condition. On line 11 I create a global variable called game over and I set it to false initially. Inside update method on raven class I create an if statement. If any raven manages to get all the way across the screen and behind the left edge of game area, game will end. If this.x is less than 0 minus this.width, set game over from line 11 to true. And inside animation loop on line 132, I only want to run request animation frame and serve the next frame of our game as long as game over is not true, exclamation mark here. When raven gets all the way across the screen, game over will be set to true and game will stop, like this. I also want to display game over message, same as we did draw score. I will create a function called draw game over. Fill style will be black. Fill text will be, for example, game over, your score is. Plus, I concatenate score variable. I want it in the middle of the screen, so x coordinate will be canvas width divided by 2, and y coordinate will be canvas height divided by 2. Now I need to call my draw game over function here in animate. If game over is false, keep serving the next frame. Else, call draw game over method to display message and final score. It's not centered. It's because these coordinates on line 101 mark top left corner and the text goes towards right and bottom from that point, same as when you are drawing rectangle or image on canvas. With text, it's easy to center by setting text align property to center like this. Yes, that worked. Same as I did with score, I want to give it shadow. I will use this trick where I draw the same text twice with different fill color, and I offset it by 5 pixels. Nice. Let's change direction of background gradient, maybe 45 degrees, 125 degrees. Let's do a little bit of experimenting now, and also to solidify what we learned today. I will use the same code pattern we used for ravens and explosions to add particle effects to our game. I will go a bit faster now, this part is just for fun. Feel free to run your own coding experiments. I create an array that will hold all my particle objects. I create particle class, constructor will expect x, y, size and color. These will be coming from outside the class and will depend on what raven is leaving this trail and creating these particles. It will be shooting from their tails. As usual, we will create properties for this.x and this.y. This.radius, since particles will be drawn as circles, it will be a random number tied to size of a raven. Let's try this formula and see what it looks like. Particles will be growing in size, so we need max radius to know when to remove them and also at which point they reach maximum opacity. It will be a random number between 35 and 55, for example. Marked for deletion, as usual, will be false at first. Horizontal speed x will be a random number between 0.5 and 1.5 because I want the particles to slowly drift to the right. This.color will be passed from the outside. Update method will move particles to the right horizontally. It will increase radius by 0.2 per frame, and it will check if this.radius is more than max radius. If it is, it will set marked for deletion to true. Draw method will just draw a simple circle. Begin path to start the drawing. Fill style will be this.color from line 101. Arc method to draw a circle. I pass it x, y, radius, start angle and end angle like this. And we fill circular path with color. We have a class that will serve as a blueprint to create particles. I want them to follow ravens as they fly to create trails behind them. To do that, I go up inside update method on raven class. Every time we serve next sprite sheet frame, at the same interval we are going to take particles array we just created and we will push new particle inside. My particle class constructor expects 4 values to come from the outside: x, y, size and color. So I pass it x and y of this raven, width of the raven as size argument, and this.color we use for collision detection rectangles will also be color of particle trail for that particular raven. You can see here on line 95, constructor wants these 4 properties to come from the outside so that it knows where on canvas to draw the particles, how large and what color. I can see I forgot to declare this.size here, like this. It will come from here and it will be used here to make radius of particle circles relative to the size of raven. Smaller ones should have smaller trails. So we have particle class. Here on line 52 we are creating new particle object and pushing it into particles array. Inside animate I use spread operator again to expand contents of particles array here so that their update method gets called. And I also expanded here for draw method. I also need to make sure old particles with marked for deletion properties set to true get filtered out from particles array. Nice, we are drawing particle trails. You can see they come from the top left corner of Raven hitbox. I will adjust that position a bit here inside particle class constructor. First I need to move this.size up so that its value is available for all properties coming after it. This.x will be x passed as argument on line 95 plus this.size from line 96 divided by 2 to center it horizontally. Yes, this.y will be y plus this.size divided by 2. No, that's too low. This.size divided by 3, much better. I want particles to be drawn behind ravens. We are drawing everything on a single canvas element, so how things are layered depends on the order at which JavaScript cycles through these objects and calls their draw methods for every frame. I will change the order here to draw particles first, and then ravens and explosions will be drawn over them, like this. Awesome, we have a working code. Let's clean it up. In update method on particle class, I want radius to grow faster. 0.5, 0.8, 0.5 is fine. Drawing trail on every single raven can be performance expensive. I want a property that will allow me to randomize it and allow me to set what percentage of ravens will have particle trails. On my raven class, I create a property called this.hasTrail. I want this property to be true for a certain amount of ravens and false for the rest. As Marcus pointed out in my generative art tutorial, any conditional expression results in a Boolean value, so instead of doing if-else statement here, I can simply just roll dice with math.random. Math.random, called like this, will return a random value between 0 and 1. So I call it and I check if that random value is more than 0.5, and that's it. It should be true roughly for 50% of ravens. This conditional expression results in a Boolean value true or false, depending on if math.random rolls a random number that's higher or lower than 0.5. I really like this syntax, very simple and clean. Inside update method on Raven class, I will only create new particles if this.hasTrail is true. Like this. Now only half of my ravens will have trails. I also want particles to animate from fully visible to transparent. Inside draw method on particle class, I set global alpha property on my canvas to be 1, which is maximum, fully visible, minus the current size of the particle divided by max size. As the particle's radius grows, eventually radius will be the same size as max radius. So let's say max radius is 30 pixels. At that point where the current radius is the same size as max radius, we will have 30 divided by 30 here, which is 1, and 1 minus 1 is 0. Particle is slowly growing more and more transparent, and at the point when it reaches maximum radius, it will be at 0 global alpha. This formula might be a bit difficult to completely understand if it's the first time you see it, but it's very useful. We will talk about it again in some other video. As you can see, global alpha is spilling over and affecting my ravens as well. That's an easy fix. If you want to change some global canvas properties such as fill style, global alpha, rotate, translate and so on, and you want those properties to affect only a single element you draw and not the others, you can just wrap that drawing code between built-in save and restore methods. Save will create a snapshot of current canvas global settings, and then we change global alpha here, which will affect just this one particular particle, and then I call restore to revert canvas settings back to what they were at this point. Save and restore are especially useful for rotating elements on canvas, but you can also use them for other things like this. My particles are blinking before they disappear. It is because JavaScript first runs over the entire array before it filters the particles that are too large out. And my global alpha formula works only in a specific range between 0 and max radius. Some particles get outside that range and are drawn fully opaque for a second before they get filtered out. To fix it is simple. I just trigger marked for deletion a little bit sooner. For example, by saying max radius -5 in my check on line 111. Let's make the trail nicer. I will add 5 particles every time instead of adding just 1. On line 54, I create a for loop like this, and I put this code inside. If I make radius grow slower, trail will be longer because it will take particles more time to reach max radius. Be a bit careful here not to have too many active particles on screen at once, because at some point it will start affecting performance and frame rate. I can also randomize the initial x and y coordinates a little. For example, I can add a random number between -25 and +25. I think it looks a bit more interesting like this. I can also add more enemy types. For example, I can add fast flying bats that will be worth extra score points. Maybe I want ravens with trails to be worth more score but also have more lives. There are many things we can do here. If you are still feeling creative, check out some of my playlists. I have creative coding for beginners, game development playlists, and advanced animation effects. Everything with just HTML, CSS, and plain vanilla JavaScript. No frameworks and no libraries. Check out some recommended courses in the video description. I'll see you there. If you want to build games with JavaScript, all you need is a small set of tools and techniques. Let's add a couple more of them to our toolkit today and make sure we really understand them. In JavaScript, the extends keyword is used to create so-called child class. That way I can have my main parent class where I define properties and values, share between all my enemy types, and then I can have child subclasses that define specifics, such as different visuals, different movement patterns, and so on for each enemy type. Then, when I instantiate my ghost object and I call update on it, if JavaScript can't find update method on the ghost class, it will go look for it automatically on the parent enemy class and it will run the code from there. There is another special keyword called super. Today I will show you exactly when and how to use it. Let's build a project step by step, completely from scratch, and in the process let's learn everything we need to know about subclassing in JavaScript and how to use it to keep our code modular, clean, and easy to read. This tutorial is for beginners. I will take you through the code in a way to make sure you understand everything. We will build a really fun animation project and I will show you many game development techniques today. This video is independent and I will explain the code from scratch, but it's part of a larger series where I teach you tools and techniques you will need if you want to be a game developer or if you just want to learn front-end web development and JavaScript on fun visual animation projects. If you code along with me today, you will get 3 free premium sprite sheets so that you can get exactly the same result. Check out this website for more beautiful game development art assets. To start my project, I create a basic web page boilerplate markup. I link style CSS file, JavaScript file, and I created HTML5 canvas element with an ID of canvas1. I bring my 3 images into the project by creating 3 IMG tags with IDs worm, ghost, and spider. You can find these images to download in the video description. It might be a good idea to use the same images as me at first and then modify the code and use your own art assets once you get everything working. It might save you a lot of time debugging if you follow exactly what I'm doing, especially if you are a beginner. I give my canvas a border, width and height, and I position it with CSS in the middle of the page. I will also hide the project images. We will draw them and animate them with JavaScript in a minute. By including images as image tags, I can make sure they are fully loaded before my JavaScript code runs. By using load event listener, it will prevent potential errors. I will show you exactly what I mean as we go along. I set up my canvas using these 4 lines of code as usual. Let's outline the entire project structure now so that you can see what functions and classes we need and how they are connected to each other. When we have the complete project structure, we will be expanding on individual parts to add more functionality. The most important thing today will be my game class. I will use it as the wrapper that contains and controls all movement and animation logic and basically everything else. It's a JavaScript class, so it will need a constructor, which is a mandatory method for all JavaScript classes. It will also have update and draw methods. In game class constructor, I create a property. I call this .enemies. My game object will hold an array that contains all enemies like this. My game class will also have a private method called addNewEnemy. This method will be called every time I need to create and set up a new enemy for my game. If method's name starts with a hash symbol like this, it will be a private class method. It means it can only be called from within my game class to manage some kind of internal functionality. In our case, adding a new enemy into this .enemies array from line 8. If you try to call this private method from outside game class, you will get an error. Notice that update and draw methods are public because I will need to call them from my animation loop from the outside a bit later. My add a new enemy private method will need a way to create new enemies for the game. So we will write another class I call enemy, and inside we declare a blueprint. Whenever I call this enemy class from inside add new enemy method, it will create one new enemy object for me. I will show you how to make animated ghosts, worms and spiders. They will all be created by this enemy class, but they will have different animations and different behaviors to make our game more interesting and maybe more difficult for the players. So again, as you know, every class needs a constructor to hold the blueprint. And we will also have update and draw methods here. Update and draw method on game object here will be handling updating and drawing my entire game. For example, all enemies, player, obstacles, backgrounds, menus and so on. Update and draw method here on the enemy class will be handling only each individual enemy, such as their position, movement pattern, sprite animation and so on. And finally, to complete the skeleton of our project, we will need a custom animate function that will call what needs to be called and loop around to move and animate things in our game. Here in animation loop, I declare what happens in our game frame by frame. At first, we will call built-in clear rectangle method, and we will clear old paint from the entire canvas, so from coordinates 0, 0 to coordinates canvas width, canvas height. If you are a complete beginner, this is horizontal x-axis and this is vertical y-axis, so point 0, 0 is here and point x200, y200, for example, is here. This is the basic thing you need to understand if you want to draw on canvas. So we cleared old paint from canvas to make sure we can only see the current animation frame. We write some code here depending on what we want to happen in our game, and we call request animation frame built-in JavaScript method, which will simply take function we pass to it and it will call it once. Animate will run its code and call itself again, run its code and call itself again, over and over. This is how you create animation loop. I don't want any of this code to run until I'm sure my web page, including canvas element and all project images, have been loaded. So I highlight all the code and I cut it for a second. I want to put it inside load event listener. Document.add event listener, and we will listen for DOM content loaded JavaScript event. I actually made a mistake here because the DOM content loaded event fires when the initial HTML document has been loaded and parsed, but it doesn't wait for style sheets and images. The correct event to listen for here is the load event, which only fires when the whole page has been loaded, including all dependent resources such as style sheets and images. So please replace DOM content loaded event with load event here. You will not notice any difference if you are working locally because images will load instantly, but if you are loading images from an online server somewhere, load event is the one you need here. So I paste all the code back here inside my load event listener. We have canvas setup, main game class, enemy class and animate function. If you want to animate something, it's important that it runs at the same speed on slow old computers and on brand new gaming super PCs. Not every computer is able to serve frames at the same speed. Also, some screens have different refresh rates and request animation frame adjusts when it serves the next frame based on screen refresh rate. So what I want to do now is count how many milliseconds happened between frames, and only when we reach certain threshold we will serve the next frame. Since we are passing animate as an argument to request animation frame here, request animation frame has another secret feature. It will pass an automatic timestamp argument to the function it calls. So our animate has access to timestamp argument, which was automatically generated by JavaScript because I called animate using request animation frame here. I want to calculate the difference between previous and current animate call in milliseconds. Difference between frames in animation is also called delta time. Simply explained, as request animation frame runs over and over, it is passing animate this automatic timestamp argument. I want to know what is the difference in milliseconds between previous timestamp and timestamp from the current loop, so-called delta time. I will calculate it by saying timestamp that was passed in this loop minus timestamp that was passed in the previous loop. I will call it, for example, last time. After I used last time variable that was holding old timestamp from the previous loop to calculate delta time, I can reassign last time to the new timestamp from this loop so that it can be used in the next loop again. Let's console log delta time to see if it works. Here I declare animate. I also need to call it to start the first animation loop. Oh yeah, last time is not declared. I declare it right here and I initially set it to 1. This value of 1 will only be used for the very first loop, because on the second loop it will get reassigned to the current timestamp. In console, I can see my delta time is around 16 milliseconds. This is a very common refresh rate for most computer screens, but if you have high refresh screen, you can get a lower number here, and if you have old computer, you can get a higher number here, especially when you create a bigger project where you animate many moving parts. At this point, even very slow computers should handle 16 milliseconds delta time between animation frames, since our game doesn't have any graphics yet. If I scroll in console all the way up to my first delta time console logs, I can see the initial call was none, not a number. It's because animate only receives automatic timestamp argument here when it gets called by request animation frame. On the very first initial call, it doesn't have any timestamp argument, so I will pass it 0 just for that first loop. Now we know how to calculate delta time, number of milliseconds between frames. Faster computers will have lower number, slower old computers might have higher delta time, because it can take them more milliseconds to serve the next frame. Since we have this delta time value, we can adjust animation speed with it to make sure our game runs at the same speed on slow and fast computers. I will show you where and how to use it as we build our project and start animate and move game characters around on canvas. Console log like this can cause performance issues, so don't forget to remove your console logs when you don't need them anymore. On line 22 I have my enemy class. It has a mandatory constructor method which will be used as a blueprint to create one new enemy object whenever I call this class with a new keyword from somewhere in my project. Let's write that blueprint, and inside we declare properties and values of our enemies. Each enemy will need X and Y starting coordinates, so that JavaScript knows where we want to draw them on canvas. I will first hardcode coordinates 100, 100. We will change that in a minute. I will also give each enemy width of 100 pixels and height of 100 pixels. Update method on enemy class will just move the enemy by 1 pixel to the left. Draw method on my custom enemy class will call built-in fill rectangle method, and it will first draw a black rectangle representing my enemy. I pass it this.x from line 24, this.y, this.width, and this.height. Great, we have enemy class. Now we can call it to create enemy object and add it to our game. Inside add new enemy private method, I take this.enemies from line 9 and I call built-in push method. Push method can be called on arrays, and it will take whatever we pass to it and it will push that at the end of the array. So I pass it new enemy. The new keyword is a special command in JavaScript. It will make JavaScript look for a class with the name enemy, and when it finds it, it will take its constructor and use the blueprint inside to create one new blank JavaScript object and assign it values and properties based on instructions inside the blueprint. That new enemy object will also automatically have access to update and draw method on enemy class. When you instantiate object with the JavaScript, it will run its blueprint inside constructor, so I will do something which might look a bit strange to you. Any code put inside the constructor will be executed when you create new instance of that object with the new keyword. So here, when I create new instance of my game object, I will create enemies array, and I will call its private add new enemy method automatically, which will push new enemy inside enemies array. To check if that really happened, I will also console log this.enemies. To execute all this code here, all I need to do is to instantiate my game class, so let's do it. Down here on line 39, I create a new constant variable I call, for example, game, and I set it equal to new game, like this. Doing that created one new blank game object, and it ran code inside constructor here on line 8. So this console log from line 11 is showing that this.enemies from line 9 contains one new enemy object. Perfect. You can see that enemy object has X and Y, width and height, as we declared here on line 25. Now, inside update method on game class, I will cycle through all enemy objects inside this.enemies array, and I will call their update method from line 31. I hope you know syntax of for each method. I'm simply saying here, take this.enemies array from line 9 and for each object in this array, run their associated update method. This is ES6 syntax, so-called arrow function. I will also take the same enemies array from line 9 and I will call draw method from line 34 on all these enemy objects. Currently there is only one inside, but there could be many more. Down here inside my animation loop, I take instance of my game class from line 39. I call update method we just wrote. And I also call draw method. And here we are animating one enemy in our game. I hope you can see advantages of code structure like this. Let's say I also have an array of obstacles, background layers, power-ups, players and so on. I can call all of these from update and draw method on my game class to get everything moving with very little code from a single wrapper function, keeping my code clean and organized this way. It's a good practice not to use global variables inside our classes, so I will take context, width and height, and I will put them inside my game class. These arguments will be passed here on line 39 when I create an instance of game class, so I pass it ctx from line 3 to tell JavaScript which canvas I want to draw on. I will define width of my game by passing it canvas width from line 4 and canvas height from line 5. These three variables, just as my game class constructor expects, here on line 8. Then I take these arguments and convert them into class properties. This.ctx is ctx passed on line 8, this.width is width, and this.height is height. Now I converted public variables into class properties and I can pass them around when I need them by passing game object as an argument. I will show you. Let's say I need width and height of my game inside the enemy class, because I want my enemies to appear behind the edges of game area. On line 23, when I create new enemy object, I will pass it this keyword, which here refers to the game object we are currently inside. That game object will carry all references to its width, height and other properties with it. Let me show you. So I'm passing this keyword and inside my enemy constructor, I will call it game. Here I created this.game property and I set it to game that was passed as an argument. Now I have access to game object from inside my enemy class. I can console log it and you can see all its properties including width and height. So now I have access to width of my game from inside enemy class by saying this.game.width. The initial starting x horizontal coordinate for enemies will be just behind the right edge of canvas. Initial starting y coordinate will be a random number between 0 and this.game height. So in this case between 0 and 800 pixels, because height of my game is 800. Now, whenever I reload page, new enemy is generated with random vertical coordinate. I achieved that by passing reference to my game class to enemy class constructor on line 23, which will take all these properties and values with it. I call it game and convert it into class property on my enemy class, making them available when I need to position newly created enemies. This is one way how you can pass class variables around if you want to avoid using global variables in your projects. I don't really want to add just one enemy when I create instance of game class. I want to create new enemies over and over in a certain interval. If I just call this.addNewEnemy from inside update method, it will create new enemy for every animation frame. That is too many and it would freeze my game very quickly. I commented out. Game class is responsible for adding new enemies to the game, so I will give it two new properties. This.enemyInterval will define number of milliseconds between adding each new enemy into the game. Let's try 400 milliseconds. This.enemyTimer will count milliseconds from 0 to 400 over and over. In update method, I can say if this.enemyTimer is more than enemyInterval, call addNewEnemy private class method. Also at that point, we want to reset enemy timer back to 0 so it can start counting again. Else, meaning if enemy timer is less than 400 milliseconds, increase enemy timer by 1. Every time we add a new enemy, I will console log this.enemies array from line 12, just so we can check if it's adding objects or not. I decrease enemy interval on line 13. Awesome, we are adding enemies, but you know how we said that each computer could run at a different speed? That could mean that enemies are being added faster or slower on some computers. I want my game to run at the same speed on every computer, and that's why down here on line 56 in animation loop we calculated the delta time. time between frames in milliseconds. I will use it now. I pass delta time to game.update method on line 58. From my previous console log, I know my delta time is 16 milliseconds. My computer can serve a new frame every 16 milliseconds. Value of delta time is dependent by the power of your computer, but also on your screen refresh rate, because request animation frame method adjusts to maximum screen refresh rate, if the computer can handle it. Now I have access to delta time value here in my update method, so instead of adding hard-coded value +1, I will add value of delta time to my enemy timer. On line 13, I set enemy interval to 400 milliseconds, or maybe 1000 milliseconds. Here I am increasing enemy timer by 16 milliseconds per frame. When we accumulate enough to reach 1000 milliseconds, 1 second, we will add new enemy to the game. If somebody has a faster computer, their delta time will have smaller value. On slow computers, delta time will have higher value and will be getting near to the target 1000 less often, but in larger steps. So in the end, my code will run at the same or very similar speed on slow and fast computers, regardless of their power or monitor refresh rate. And this is how you use delta time to trigger periodic events in your games or animation projects. I also need to make sure I'm passing the reference to my canvas properly and not using global variable. Let's follow the logic. We declare CTX here on line 3. I passed that global variable to my game class when I instantiate it on line 52. On line 9, I take that argument and I convert it to class property. Then I pass CTX from line 9 to draw method on my enemies. And on line 47, I need to make sure draw method on enemy class expects that argument. And this way, line 48 is using this.ctx that was passed around from game object rather than using global ctx variable. I'm console logging this.enemies array on line 20 and I can see it keeps growing. I need a way to remove enemies that have left the screen. We could potentially also use something called object pooling here, but I will leave that for another episode. First, I will need a flag on my enemy objects that will mark them as ready to be deleted, and then we will simply filter these objects out. I will call that property this.markedForDeletion, and I initially set it to false. Then, inside update method on enemy class, I will check if this.x is less than 0 minus this.width, meaning the enemy has moved across the screen and behind the left edge of canvas. If it has, I will set its markedForDeletion property to true. Now I can go inside update method on game class, and here I will take this.enemies array from line 12, which currently has around 20 objects, and it keeps growing, and I will filter it. Filter is a built-in JavaScript method that manipulates arrays. It simply creates a new array with all elements that pass the test implemented by the provided function. So here on line 17, I'm saying take this.enemies from line 17 and reassign it to the same array, but only include elements that have this.markedForDeletion property set to false. Exclamation mark here means false. Let's run the code and see if it works. Yeah, we stop at 10 enemies and it's not growing anymore because we are removing old ones as we are adding new ones. Might be one good performance idea here. You don't have to check and filter enemies for every frame of animation. We could, for example, do it in a certain interval. I could even take this line of code and put it inside this if statement. It would still filter old enemies, but it would run only periodically whenever I add a new enemy to the game. We are making nice progress. We have already implemented so many features. Here between lines 35 and 53, I have my enemy class. It's a blueprint with properties and methods that determine what my enemies look like, how they move, and how they behave. Let's expand on it and make them more interesting rather than simple black rectangles. I will create a so-called subclass or child class by saying class worm extends enemy. Doing that will make enemy a parent class of worm. And for example, if I call update or draw and JavaScript can't find that method on my worm class, it will automatically go looking for it on the parent class. So it will look for that method on enemy class. Same goes for properties declared in constructor. If there is no constructor on my worm class, it will automatically use the constructor from enemy. When I do this, I can have shared enemy class that declares all logic, properties, methods and features that all my enemies have in common, for example their sprite animation logic, collision checks with player and so on, while at the same time I can declare child classes where I can override, improve and change some of these properties and methods to create unique and very different behaviors for different enemy types. And that's exactly what we will do now. Let me show you how much visual and behavior variety we can create without repeating the code all enemies have in common. Doing this will keep our code clean and modular, and you can go crazy with different enemy types while still keeping your logic organized and easy to read. On my worm class, I don't have to declare constructor at all, and JavaScript will automatically use constructor from line 36 on enemy class. But in most cases, you want each enemy to have different width, height, X and Y position and so on, so I kinda want to use both. I want to take all properties from enemy constructor and I want to add some additional properties on top of it. That will be specific only for my worm objects. I declare constructor and I know worms will have unique value for image property, so this.image equals worm. This line of code is a weird syntax and I will explain what's going on and how come it works when I bring image to my project this way in a minute. Let's first finish constructor method on worm class. Same as on line 36, worm class constructor will expect game as an argument. Now I want to say take all the code between lines 37 and 43 on enemy class constructor and use it here. To do that, we use special super keyword. The super keyword is a special command in JavaScript and it's used to access and call function on an object's parent. So here I call super and I pass it game to literally run the constructor on its parent class. After that, I can add more properties on my worm class constructor like this. Important thing to note here is that you have to first call super and run parent constructor like this before you declare any additional properties using this keyword. Otherwise, you will get a reference error. In derived classes like this, super must be called before you can use this keyword. So now, my worm constructor contains all the code from between lines 37 and 43, and additional this.image property set to worm. Each enemy type will have different starting X and Y coordinates and different width and height, so I will actually take all these and put them on my worm. I want enemy class constructor to have only properties and values that are shared for all my enemy types. Up here on line 31, inside private add new enemy method, rather than instantiating parent enemy class, I will instantiate child worm class. Again, I'm passing it this as an argument, and because we are inside game class, this reference is the entire game object, so all these properties. We travel down to worm class, and inside constructor we are taking that game and passing it to super, instantiating constructor of its parent enemy class, which is here. Enemy class also has update and draw methods, and when I call update and draw on my worm and JavaScript can't find it, it will automatically go looking for them on the parent enemy class. I hope it's becoming a little bit more clear how this works and how parent and child classes relate and work together. If I run the code, we have our worms coming again. Just to prove that draw method that is called from line 46 is taking properties from worm class constructor, let's change this.width on line 56. As you can see, now my worms are 200 pixels wide. So what is this weird syntax on line 58? This is not how we usually bring images into a project. Usually I would use getElementById to target my image element with an ID of worm that I created in index.html in the beginning. I wasn't aware of this, so all the credit goes to Danny, who says, a little known fact is that any elements created in the DOM with an ID attribute are automatically added to the JavaScript execution environment as a global variable. This means that you can access any HTML element with a JavaScript using its ID. No need for document.getElementById or query selector. I'm just doing this as an experiment and you will see in a minute that it actually works. If you're having any issues, you can still bring the image into the project the usual way and also ideally pass it to the worm class constructor as an argument so that we are not pulling global variables directly from the outside. I'm just experimenting here a bit. I really like tips like this. Thanks, Danny. Nowhere in my code have I declared this worm variable. The only place you can find this reference is ID on line 12 inside index.html. But this image will still work. You can test it by console logging this.image. I have too many console logs. Let's comment out line 38. Yes, you can see that the JavaScript is actually finding the image with an ID of worm automatically without us having to use getElementById like we usually do. So let's use that image and make our worms look a bit better than black rectangles. You can download these sprite sheets for free in the description, and you can use them to follow along with this video for educational purposes. To use them in any commercial projects, you would have to buy a full license from the artist's website. I will link his site as well. He has a lot of great game development art assets there, check it out. I feel like I explained built-in Canvas draw image method 100 times on this channel. This method is so important. At first I will just use the version with 5 arguments. Image we want to draw, X, Y, width and height, where to draw it on canvas. This way we will just squeeze the entire sprite sheet with all its 6 frames into the predefined area of 200 × 100 pixels. Notice that I'm calling draw method on my worm class. It's using these properties, but since JavaScript can't find draw method on worm, it will look for it on parent enemy class and it will use that one. Let's remove this console log and this fill rectangle as well. I can change width and height, but now I would actually like to draw just the first frame from the worm sprite sheet. I remove all these lines I commented out earlier. I create a new property on worm class called this.spriteWidth, and it will be a width of a single frame in my sprite sheet. If I take width of my sprite sheet and divide it by 6, the number of frames, I will get 229 pixels. Height of a single frame is 171 pixels. I take width and height and move them up here. Now I need to use draw method to cut out just a single frame from that sprite sheet and place it on canvas. For that I will need to give it 9 arguments, so additional 4. To tell JavaScript what area I want to crop out from the source image, I need to give it source X, source Y, source width and source height arguments. Source X and source Y will be 0, 0 since I'm just cropping out the first frame for now. Source width and source height will be this.spriteWidth from line 52 and this.spriteHeight from line 53. So to crop out a single frame from an image with drawImage method, I need to give it 9 arguments. Image I want to draw, X, Y, width and height of what area I want to crop out, and X, Y, width and height of where on canvas we want to place that cropped out piece of image onto. Now we are drawing just one frame, perfect. You probably noticed that it's a bit stretched. That's because this width and height, which is coming from here, has no relation to the actual size of a single frame, so the ratio is different. Let's make width and height the same aspect ratio as our sprite sheet. I do that by making width half of sprite width and height will be half of sprite height. I needed to do half because the original size would be too large. As long as I use the same modifier on both, width and height, in this case I divide both of them by 2, it will preserve the aspect ratio of the original sprite frame. All my worms are moving to the left by 1 pixel per frame. What if I want each worm to have different speed? For example, a random value between 0.1 and 0.2. And up here inside update method on enemy class I say this.x minus equals this.speed. That will be very slow. Let's make it faster. You might have realized that I'm not using delta time in this movement calculation, so let's use it to make sure the worms move at the same speed on all machines. I'm calling this update method here on line 25, so I pass it delta time, which we made available here before. Now that I have access to delta time in update method on enemy class, I will pass it here as an argument. And to factor in time difference between animation frames when moving something around, we have to multiply it. That way, faster refresh rate with lower delta time will move often, but by smaller steps. Slower PCs will have higher delta time. They will not draw frames so often, but they will have higher delta time, so they will make larger steps to compensate for the difference. Now the base speed is too much, so I amend it on line 59. I will actually rename it Vx, velocity on horizontal x-axis, because maybe some other enemies will have a vertical movement. Also, I need to rename it on line 41. If I go up on line 13 and reduce enemy interval to 100 milliseconds, we will get a lot of worms and something will become apparent. they are layered randomly in order as they are added to the game. For example, this worm should be probably behind this one, and this one behind this one. If we pretend this is 3D game space and worms that are higher should be behind worms that are lower, it would look better. How do we achieve that? Z-index, or whether worm is in front or behind other worms, depends on order at which they are added to the array, on their index in that array, because as I push them into enemies array one by one, we cycle through them from index 0 to the maximum index in that array, and we draw worm with index 0, then worm with index 1 on top of it, if they are in the same area, then worm with index 2 will be on top of them, and so on. I want to reorganize my array so that index in the array is tied to their vertical position, so that we first draw worms in this area, and then we draw the ones in this area on top of them as we go down on the page vertically in plus direction on vertical y-axis. That will cause worms to look like they are properly behind each other and not messy like this. Look at this, this is a mess. This one is sliding over the other one's eye. So every time I push new worm into the array, I will just build JavaScript sort method. You can simply just call sort on the array and it will sort them in ascending order by default. If you want more control, you can give it a callback function. Sort simply takes every element in the array and it performs a check comparing values between these two elements, pushing them up and down in the array, depending on the condition in the callback. I want worms with lower vertical y-coordinate to have lower index so that they are drawn first. So my condition will be a.y minus b.y like this. Sort is a built-in JavaScript method. It abstracts away the actual algorithm that does the sorting work, so let's not spend more time on it now. All we need to know for now is how to use it. When I run the code, you can see that worms that are higher are drawn behind the worms that are lower, making it look like they are moving in actual 3D or maybe in 2.5D cartoon space. Well, it doesn't look messy anymore. You can swap between ascending and descending order by swapping these values. In our case, we want a minus b. Also notice I'm not sorting the array for every animation frame, only when I add new enemy into the array. So this is our worm class. It's a child of enemy and it doesn't have update and draw methods because, as we said, if JavaScript doesn't find them on the worm class, it will go looking for these methods on the parent class. But what if I want to use the base code from draw method on enemy class and I want to add some extra code to it to create some additional visuals? For example, as Boris suggested, ghosts need to be semi-transparent, but I don't want reduced opacity on worms, only on ghosts. So how do we do something like that? I'm sure you can come up with some clever if statement, but let's keep it clean and use child classes for that. I will copy my worm class and rename it to ghost. Image on line 74 will be ghost, referencing the ID here on line 13 in index.html. I look at my sprite sheet, width divided by number of frames, so sprite width of single frame is 261 pixels, height is 209 pixels in this case. Horizontal speed modifier will be a little bit higher than worms. Let's say a random number between 0.1 and 0.3. So that's the base ghost child class. How do I randomly push worms or ghosts into my game? One way to do that is to create a property on my main game object called this.enemyTypes. It will be an array with two elements for now, worm and ghost. Inside add new enemy private method, I will randomly pick one of the options in the array. I create a constant variable called random enemy and I set it equal to this.enemyTypes and square brackets. So if index here is 0, we get worm, and if index here is 1, we get ghost. How do I randomize this index and let it choose one of these randomly? Every time we run add new enemy method, I can just put math.random statement and it will be a random number between 0 and length of this.enemyTypes array. That way I can keep adding more and more enemy types to the array and this code will still work. Maybe my game will have 20 different enemy types, it doesn't matter, it will still work. The only problem is that math.random returns numbers with decimal points and there is no index 1.5 in this array. It's easy to fix. I will wrap it inside math.floor, which will round it down to the closest integer. Now I can check if random enemy variable is worm. We will push new worm into this.enemies array. else, if random enemy is ghost, we will push new ghost. Perfect. So we have this.enemy types array on the main game class. This can contain as many enemy types as you want. Inside add new enemy, we randomly choose one of them every time we are about to create new enemy object, and based on that random choice we create either worm or ghost. So now both worm and ghost are child classes that extend my main enemy class. Let's switch to kind of flat 2D view. I want worms to move only on the ground, so I change their vertical Y position to this.game.height minus this.height. Worms are sliding on the floor, ghosts are flying in the air. I want ghost to take up only the top 80% of the game area, not to be so close to the ground. Their vertical Y position will be a random number between 0 and game height times 0.8. Or maybe 0.6? Yeah. Since we switched to this new view, I don't really need to be sorting my enemies by their vertical position anymore, so I comment out this code on line 35. With both worm and ghost, we are only modifying properties on the constructor. They both inherit the same identical update and draw method from the main enemy class with no modifications at the moment. We said we wanted to make the ghost semi-transparent, so let's do it. I declare draw method on ghost class, and now two things can happen. We can override the draw method with a completely different code here. Because when we create a new worm, JavaScript will not find the draw method and will go looking for it on enemy parent class, but with ghost, it will find the draw method right here, and it will ignore the original draw method on enemy class. The second option is that I want the code from draw method on enemy class to run, plus I want to write some additional code on top of it that will be unique only for ghosts. I can do that by calling super. The super keyword here simply represents parent class, so imagine I'm saying enemy.draw, because I want to call its draw method first. Super.draw means enemy.draw basically. Super represents the super class, the parent class. So here inside the draw method on ghost class, first I call draw method on enemy class, and I know it expects ctx as an argument, so that it knows what canvas we want to draw on. That ctx property is coming from here on line 29, by the way, where I'm calling draw on all objects inside this.enemies array. I'm calling draw on all ghosts and all worms at the same time. So first we call draw method on parent enemy class from line 50. We will run all the code in here. But we will also add some additional code that will be specific only for ghost objects. In this case, I will set global alpha property to 0.5. This will set opacity to 50%. You can see that it affects all ghosts and all worms as well. It's because global alpha canvas property works the same as fill style, for example. Once you set it, you are setting it for the entire canvas. It will stay that value for everything drawn on the same canvas unless you redeclare it to something else. Since I want global alpha to only affect ghosts and nothing else on canvas, I set it to 0.5, I draw my ghost and I set it back to 1. The alternative way to do this would be to call ctx save built-in method, which will take a snapshot of all canvas settings at that point. Then we can change global alpha and anything else we need to change. We draw the ghost and we call ctx restore, which will automatically restore canvas properties, including global alpha, back to what they were at this point when we called save for the first time. This technique is especially useful if I was changing multiple canvas properties at the same time, not just global alpha. So this is how you extend a method from parent class with the help of super keyword. Now that we know how to do it, we can also extend update method and make ghosts move in wavy patterns. Let's try. I redeclare update method on ghost class and I pass it delta time. I call super.update and I pass it delta time. This will run all the code in update method on enemy class from line 46. Here. I add a new property called this.angle and initially I set it to 0. Then in update method I will say this.y vertical position of my ghosts plus equals math.sign built-in JavaScript trigonometry function and I pass it this.angle as an argument. I covered this in my enemy movement patterns episode as part of this series before, so now just quickly. Math.Sign is a built-in JavaScript function that returns a sign of a number we pass to it. It expects angle value in radians and it will return a value between -1 and +1. If you keep calling it and passing it ever-increasing angle value, as we are about to do here, it will endlessly cycle by small increments between -1 and +1, creating wavy movement pattern, so-called sine wave. So every time update method runs, I will increase this.angle from line 79 by 1. That angle value is being passed to math.sign function here at the same time. You can see it makes the ghost shake up and down. We can also multiply it times a certain radius value. This will make the curve larger, like this. We need to be increasing angle much slower. Let's try 0.1 per frame. 0.05, 0.02. You can see how that affects the movement curve. I change radius value. And angle value. Let's randomize the wave size for each ghost. I create a property I call, for example, this.curve. It will be a random number between 0 and 3. And I use it here. Now some ghosts move in smaller, some in larger waves. I reduce the number of enemies by increasing enemy interval on line 13. Let's add a new enemy every 500 milliseconds, for example. So with Ghost class, we are extending draw method to make it semi-transparent and update method to give it wavy vertical movement. Worm class is just using the base draw and update methods from its parent enemy class. Let's create another child class and let me show you a completely different type of movement for the third enemy type. I just copy worm class here so that I don't have to write all of that again. I will call it spider. I check my sprite sheet, sprite width. Width of a single frame is 310 pixels. Sprite height is 175. I want spiders to start from just behind the top edge of game area, so 0 minus this.height. Their horizontal speed will be 0. I only want them to move up and down. Image will be spider, referencing this ID from line 14 in index.html. I give them vy, velocity y property, and set it to 1. Now I create update method. I pass it delta time. First, I call update method from parent enemy class from line 46. And then I add some additional code. At first, let's just increase vertical speed by 1. On line 15, I add spider to my enemy types. And here I say else if random enemy is spider, push new spider object into enemies array. My spiders are not showing, and that's because, yes, they just move down and their horizontal coordinate is off canvas, so we can't see them. I set their horizontal coordinate to be a random number between 0 and game width. Nice, we have spiders here. Let's make them move up and down. Let's say if this.y is more than 200 pixels from the top, revert this.vy to a negative number, since we are adding this.vy to vertical position here on line 110. If it becomes a negative number, it will make the spider go up. Awesome, we have spiders going up and down. What about instead of hard-coding 200 here, each spider will have a different maximum movement range. This.max length is a random number between 100 and 300, for example. Actually, between 0 and game height might be better. Now I just replace hard-coded 200 with this.max length here. I also want each spider to move up and down at different speed, so this.vy is a random number between 0.1 and 0.2. I should also multiply it times delta time so we get consistency across different machines. I want the spiders to swing up and down from a spider web, so let's extend draw method as well and draw it. First, I will call draw method from parent class from line 51. Here on line 88 I need to pass ctx as an argument. I forgot to do that. We don't want to use global variables inside our classes. So on line 114, I pass draw method ctx. I call draw from its superclass from enemy parent on line 51 to run all the code in there. And also I will draw a spider web here, so begin path to start a new shape, built-in canvas move to method to set starting coordinates of the line. Let's pass it coordinates 0, 0 for now. Line 2 will be the ending coordinates of my line, so this.x, this.y. I want it to be where my spider is at the moment. I stroke the lines and here they are. We have spider webs coming from coordinates 0, 0 to coordinates of my spiders. Let's change the starting coordinates to be exactly on top of the spider horizontally, so this.x horizontal and 0 vertical. This.x position is top left corner of my enemy rectangle, so if I want the web to come from the middle, I need to take this.x position and add half of enemy width to it. I also do that for the starting coordinates. I can see there is a small vertical gap between spiders and the ends of their webs, so let's do this.y plus 10 pixels to make the lines a bit longer. Notice that I'm not actually animating the sprite sheets, we are just showing the first frame for each enemy type. The best thing about our code structure now is that I can just write sprite animation logic once and it will automatically be applied to all spiders, worms and ghosts. I go up to line 46 inside constructor on enemy class, where I declared properties and values that are shared between all enemy types in my game. We will need frameX property, which will cycle between 0 and 5 to specify which horizontal frame from the sprite sheet we want to show. I also declared this.maxFrame, which could be specific to each enemy, but in this case all my enemy sprite sheets have 6 frames. We count from frame 0, so max frame is 5. I also need to account for delta time when animating frames to make sure it runs at the same speed on slow and fast computers. We already done it once today. I will have a frame interval variable, so let's say 100 milliseconds, and then I will have one accumulation variable that will be going from 0, accumulating delta time until it reaches my frame interval value. I will call it, for example, this.frameTimer. I set it to 0 initially. I check if this.frameTimer from line 49 is more than frame interval from line 48. If it is, I do something, else I increase frameTimer variable by delta time. Now I just realized we need access to delta time here, so all this code actually needs to be inside update method. Here. Now I can say frameTimer plus equals delta time. Remember that delta time is milliseconds between frames, so fast computers will serve frames of our game animation very fast, but will have smaller delta time. On the other hand, slow computers can't serve frames so often, but their delta time is larger, so as a result it evens out and both fast and slow computers will reach frame interval of 100 milliseconds at the same time. This will ensure all the movement and animation in our games has the same timing, regardless of speed of the machine we run the code on. frameTimer will start at 0. It will be increasing by delta time, and when it reaches frame interval, we can move to the next frame in sprite sheet. I have to check if current frameX from line 46 is less than max frame from line 47. If it is less, we increase frameX by 1. Else, we set frameX back to 0. At the same time, I set frameTimer back to 0, so it can start accumulating delta time again. On line 46, I set frameX initially to 0. Now I'm cycling between frameX 0 and frameX 5. To actually display that in game, I have to replace hard-coded sourceX and sourceY properties in drawImage method, which I set to 0, 0. I have to replace them with my new variables. SourceY can actually stay hard-coded to 0 because our sprite sheet has only one row. There will be no vertical navigation within this sprite sheet. SourceX argument will be frameX from line 47 times sprite width from line 70. That way, when frameX is 1, we cut out this frame, frameX2 is this frame, and so on. I have an entire episode on this as part of this series if you want more details about how to animate sprites properly, and in that episode I also show alternative techniques how to do this. I can also add more functionality here in update method on enemy class, and it will be shared across all my enemy types. It could be, for example, collision checks with player, some JavaScript generated sounds, enemies can have particle effects, and so on. Being able to write code here in one place and share it for all my enemy subclasses will save a lot of code repetition that would happen otherwise. On line 53, I'm checking if enemies have moved behind the left edge of screen, and I'm marking them for deletion. This check works for both ghosts and worms as they move from right to left. The problem is that spiders never move past that point, they have no horizontal movement. So as you can see in the console, if I let my game run, it will just keep accumulating more and more spiders. I need a different check here to mark spiders as ready to be deleted. I go inside update method on spider class and I say if this.y is less than 0 minus this.height times 2, then mark it as ready for deletion. Spiders start at 0 minus this.height as declared here on line 114. They will move down and then they will move back up. When they reach point 0 minus this.height times 2, we delete them. I will be extending classes a lot in my games, so I hope you learned something new today. Creating child classes is not only useful for animations and game development, but it's a very important JavaScript technique with many different applications across all front-end web development. I think sometimes it's better to learn these concepts on fun projects like this. To learn more fundamental JavaScript techniques on creative coding projects, check out related videos in the video description. Great job on completing today's course. Say hi in the comments. Hey coders, so I heard you like making games. Me too. I think projects like this are great not only for aspiring game developers, but also to learn and improve HTML, CSS and JavaScript skills. In this class we will build easy animated side-scroll game completely from scratch with plain vanilla JavaScript. No frameworks and no libraries. The main goal today is to learn about basic code structure, how to split responsibilities between objects that make up our game, how to make them communicate with each other effectively, and how to put all of that together in an easy to understand way. This class is a part of a longer series. In each episode we built a small standalone project for beginners to learn about fundamental building blocks of game development with the JavaScript. Full series is linked in the description. In this part we will build a simple version of the game to learn the fundamentals. In the next part we will expand on each element using the things we learned across the series. Let's see how it all comes together. Games should be exciting, full of secrets and special features. I hope this series helps you to bring your creative ideas to life. We will work with 3 files. In index.html I link my CSS style sheet and the JavaScript file. I create HTML5 canvas element with an ID of canvas1 and I put all my game assets here in this area, so that we can use load event listener to wait for these assets to be fully loaded and available before we run the game. Art assets were provided by this talented artist. You can find more on their website. I will have player image, background image and enemy image here. You can download project files in the video description. In style CSS I give my body black background. I make canvas blue and I position it in the middle of my web page. I also want to hide my image elements because we will draw them with JavaScript on canvas, so player image, display none. Same goes for background image and enemy image. I want JavaScript to wait until all images are fully loaded, so I will wrap my game inside an event listener. We will listen for load event. Load event waits for all assets such as sprite sheets and images to be fully loaded before it executes code in its callback function. I will place the entire code of our game inside this anonymous callback function. In JavaScript, anonymous function usually means a function without a name. By placing all my code inside this anonymous callback function, I separate scope of my game from a global scope to make sure my custom class and variable names don't clash with any other outside code. When all the assets are fully loaded, the code inside will be executed line by line. I assign variable to my canvas element. I create context, instance of built-in Canvas 2D API that holds all drawing methods and properties we will need to animate our game. I set canvas width to 800 pixels and canvas height to 720 pixels. I make canvas transparent. In this class, I want to make it very clear how we split responsibilities between objects and how these objects interact with each other to create a complete game. So let's just write all the building blocks we will need today. Our game will need input handler class, which will apply event listeners to keyboard events, and it will hold an array of all currently active keys. Player class will react to these keys as they are being pressed, drawing and updating the player. I will have a simple separate class that will handle endlessly scrolling backgrounds. We will also need a class that will generate enemies for us. We will have multiple active enemies in our game, so I will have a function called handleEnemies that will be responsible for adding, animating and removing enemies from the game. I will have a utility function I call, for example, displayStatusText, which will handle things like displaying score or game over message. And lastly, we will have main animation loop. This function will run 60 times per second, updating and drawing our game over and over. So that's it. Here we can see all the building blocks we need to create a complete game. I could have wrapped everything in a main game class, for example, but I'm trying to keep it clean and simple today. Input handler class will apply event listeners to the game, and it will keep track of all keys that are currently pressed down. Inside constructor, I created this.keys property and I set it equal to an empty array. The way I want to handle controls today will be a bit different from my previous courses. I want to have an array and I will be adding and removing keys from it as they are being pressed and released. That way I can keep track of multiple key presses. I will place event listener directly inside the constructor. When we create an instance of a class, all the code inside constructor is executed. Because of that, just by simply creating an instance of input handler class later, all event listeners will be automatically applied. I will have event listener for key down event. Callback function on event listener has access to this built-in event object. I will assign it a variable name, for example e, and I console log it. Now I create an instance of input handler class, which will run all the code inside constructor. So at this point, the event listener is applied. Let's test it. When I click my canvas and I press key on keyboard, I can see this event object here. It contains all different details about keyboard event that just occurred. What I care about today is this key property. It contains a string that represents name of key that was pressed. So to get that value directly, I say e.key. Now I'm getting those values as console logs. I care only about arrow keys right now, so I say if e.key is arrow down, take this.keys array from line 9 and push that value inside. I move this console log here, and I will also console log this.keys. We will get an error. This.keys is undefined. JavaScript cannot find it. It's because I'm instantiating input here, and the event listener is called from window object. By the time that event listener is called, JavaScript forgot that this keyword refers to this input handler object and it's this.keys property. To make sure this keyword points to the correct object, I can use JavaScript bind method, or I can use ESX arrow function. Arrow functions don't bind their own dis, but they inherit the one from their parent scope. This is called lexical scoping. Doing that will make sure JavaScript doesn't forget which object this keyword stands for, and it will work. You can see pressing arrow down adds an entry into this.keys array. I don't want to have multiple entries for each key. Here we can see it added arrow down 4 times. I only want to add it if that specific key is not in the array yet. So I do second condition here and I say if this.keys index of e.key, key that was pressed, is equal to -1. With arrays, if index of is equal to -1, it means that element is not present in the array. So I'm saying if key that was pressed is arrow down, and if that key is not yet inside this.keys array, only then push it into the array. Now you can see that when I press arrow down multiple times, it adds it to the array only once. Perfect. I copy this code block and I turn it into key up event. If key that was released is arrow down, I want to remove it from this.keys array, so I call splice that takes 2 arguments. Index of element we want to remove and how many elements starting from that index we want to remove. So I find index of arrow down inside this.keys array by using index of method again. And second argument to splice, I want to remove 1 element at this index. So here I'm saying when we release a key, If that key is arrow down, find index of that key inside this .keys array and use splice to remove one element from that array. Now, when I press down arrow key, it's added to the array. When I release it, it's removed from the array. Nice! Let's also listen for other keys using OR operator. I start with arrow up. Then we also need to listen for key down on arrow left and arrow right. I'm gonna break this down on individual lines for clarity, and I use tab key to make them vertically aligned. Be careful here not to forget a bracket, otherwise the code will break. I will also listen for the same 4 keys inside key up event. So we have this .keys array here. In key down, if arrow down, up, left or right is pressed, and that key is not yet present in this .keys array, we push it into the array. In key up, when any of these 4 arrows are released, we find index of that key inside this .keys array, and we use splice method to remove it. This .keys array now holds information about which arrow keys are currently pressed down. Sometimes it could be multiple ones at the same time. I remove these console logs by instantiating input handler class here on line 50. All the code inside constructor on line 8 will be executed. We have this .keys property as an empty array, and we use key down and key up event listeners to add and remove specific keyboard inputs from that array. And now we know how to handle keyboard inputs in a game. We will use them to move player around in the next part. Player class will define properties of player object. It will draw it, animate it, and update its position based on user input. Player object needs to be aware of game boundaries. We don't want it to run off screen, so I pass it game width and game height as arguments, and I convert them into class properties like this. I'm using sprite sheet of specific size. Here we have frames of width and height of 200 pixels. It's a good practice to size your sprite sheets to the actual size you will use in your game. I can also resize them with code, but it's cleaner to have art assets of the right size. This .x will be 0 and this .y will be 0 at first. Player object will have public draw method. It will expect context as an argument to specify which canvas we want to draw on, in case we want multiple layers and multiple canvases in our game. I will start by calling built-in fill rectangle method to draw a rectangle to represent our player. I pass it x, y, width and height. Since I have black background, I set fill style to white so that we can see the rectangle. On line 62, I create an instance of player class using the new keyword. Here on line 31, I can see player class constructor expects game width and game height as arguments, so I pass it canvas width from line 4 and canvas height from line 5. I get an error, game width is not defined. It's because I made a typo here on line 32. Now it works, and I can display our player by calling its public draw method we just wrote. It expects context as an argument, so I pass it ctx from line 3. I can move player around by adjusting its x and y coordinates. Let's make it stand on the bottom of game area, so this .game height minus this .height. We will also need update method to move player around. Let's start by increasing player's horizontal x coordinate by 1 for every call of update method. If I call update method just like this, there won't be any visible movement. I put it inside animation loop, and I use request animation frame built-in method to make it loop. I pass it animate, the name of its parent function, to create endless animation loop, and I call animate like this to start it. I also need to put draw inside. I delete this. We can see trail behind player rectangle. I want to only see the current animation frame. To delete old paint from canvas, I use built-in clear rectangle method. It will delete entire canvas between each animation loop. Perfect, now we have player moving from left to right as we defined in its update method. Instead of drawing a white rectangle, let's draw a player image. I call built-in draw image method. I need to bring player sprite sheet into the project, so this .image property is document.getElementById, and I give it ID of player image. I pass this .image from line 38 to draw method and I pass it x and y of 0, 0, so top left corner of canvas, it will just draw the entire sprite sheet at these coordinates. I pass it this.x and this.y instead. You can see it just draws the entire large sprite sheet with all the frames. DrawImage method can accept optional 4th and 5th arguments for width and height. It will then stretch or shrink the image to fill all available area, like this. I actually just want to draw one frame, so I pass it another 4 optional arguments: source x, source y, source width, and source height. These define a rectangle we want to crop out from the source sprite sheet, and destination x, destination y, destination width, and destination height define where on destination canvas we want to place that cropped out rectangle onto. I pass it 0, 0 as source x, source y, and we are cropping to this.width, this.height, so this area. Now we can see top left frame in the sprite sheet. I can use source x and source y to jump around the sprite sheet. By changing value of source y, we can jump between different rows. By changing the value we pass as source x, we are navigating within the sprite sheet horizontally. Let's just turn these values into class properties, called, for example, frame x and frame y. I replace them here, and now we can navigate around sprite sheet by changing values of these properties. Perfect. I comment this line out. The movement will work this way. We will have this.speed property. Initially, I set it to 0. We will be adding this.speed to this.x at all times. When it's 0, there will be no movement. When this.speed is a positive number, player will move to the right. When it's a negative number, player will move to the left on the negative direction on horizontal x-axis. Now we can connect keyboard inputs to player movement. Update method will expect input as an argument. I take input from line 69 and I pass it to player update method here. We are interested in this.keys property from line 9, which holds all currently active keys. We can access that property from input argument we are receiving here. So this section will deal with horizontal movement. If input.keys contains arrow up, so if index of arrow up is more than -1, run the following code. Actually, let's start with arrow right and set this.speed from line 41 to 5. When arrow right is found in this array from line 9, set player speed to 5. It will make player to move to the right. But there is nothing to set speed back to 0, so it never stops moving. I create an else statement here, and inside I set player speed back to 0. Now player moves to the right only when I hold down right arrow key. Nice! I do else if statement here. Be careful about the brackets. It's easy to get it wrong and get an error here. Else if arrow left is pressed, set player speed to -5. Now I can move player left and right. Player can easily move off screen if we hold the arrow for too long. Let's introduce some horizontal boundaries. If horizontal x coordinate is less than 0, set it back to 0. Now we can't move past the left edge of game area. Else if player's horizontal coordinate is more than game width minus player's width, meaning right edge of player rectangle is touching the right edge of canvas area, also don't allow it to move past this point. Perfect. Jumping is a bit more complicated, but it's not that hard. I say if arrow up key was pressed, set velocity y property to -30. I set velocity y property on player object, and initially I set it to 0. Let's just move this around so that I have controls in one place. Horizontal movement separate, and I create a section for vertical movement. Actually, this line also belongs under horizontal movement, here. At all times, I will be adding velocity y property from line 42 to player's vertical coordinate from line 37. Initially, velocity y is set to 0, so we will get no vertical movement. When I press up arrow key, velocity y is set to -30 and player just flies off screen. I need a force that will push in the opposite direction. I can call it gravity or maybe weight. I set it to 0 at first. I need a check to see if player is in the air or standing on ground. I will need that check in multiple places, so I might as well make it into a utility method like this. I call it, for example, on ground, and it will return true or false based on how this statement evaluates. If this.y is more or equal to game height minus player height, we know player is standing on solid ground. Here in vertical movement section, I say if on ground is false, meaning if player is currently in the air, take velocity y and start gradually increasing it by this.weight from line 43. I set this.weight to 1, we jump, and eventually player falls back down. Size of the jump depends on how long you hold up arrow key. We don't want it to work like that. Let's fix it. When we press up arrow key, I set velocity y to -10 so we can see it better. I create an else statement here, and inside we set velocity y back to 0. So if player is in the air, gradually add more and more weight to velocity y. Else if player is back on ground, reset velocity y back to 0 to stop vertical movement. If I jump too high, player partially falls through the floor before velocity y is reset back to 0. To prevent this from happening, let's introduce a vertical boundary on the ground level. If player's y coordinate is more than game height minus player's height, I set it to game height minus player's height. Player can never be below this point. That works. The height of jump is still dependent on how long I hold up arrow key, because each tick adds another -10 to velocity y. Also, if I press up arrow over and over, player will keep jumping higher and higher. We only want player to be able to jump when it's standing on solid ground. Here on line 55, I say if up arrow is pressed and if player is on ground, only then decrease velocity y by -10. Now we can't double jump anymore. Let's do -30 for a bigger jump. Maybe -32. So jumping works like this. Velocity y is 0. When we press up arrow key, velocity is immediately set to -32. This statement on line 66 becomes true, and weight of 1 is being added over and over to velocity y. That will make velocity y go from -32 to 0 and then back to positive numbers, so player will go up, it will gradually slow down, stop, and it will start falling back down again as the value of velocity y goes from negative into positive numbers. When we hit the floor again, line 69 will set velocity back to 0 and the jump is complete. When we jump, we want to animate a different row of sprite sheet. I want this jumping animation, so I set this.frameY to 1. When we land back on ground, I set frame Y to 0. Endlessly scrolling backgrounds are very easy to implement. I made a special episode about different techniques I like to use and how to split it into individual layers for parallax effect. Today we will just do a single endlessly scrolling layer. Constructor will expect game width and game height, and I convert these arguments into class properties. This.image will be my background image. I give it an ID of background image, spelled like this. This.x will be 0, this.y will be 0. I check my image and I can see its width is 2400 pixels. Height is 720 pixels. Draw method will take context as an argument to specify which canvas we want to draw on. I call built-in draw image method and I want to draw this.image from line 84. I pass it x and y. On line 109, I instantiate my background class by calling the new keyword. I pass it game dimensions, so canvas width and canvas height. Inside animation loop, I call background.draw. Draw method from line 90 and I pass it ctx as an argument. We are drawing everything on a single canvas element, so I need to draw background first before I draw the player, so that the player is visible. Now I want to make the background animate to the left. First I pass it width and height here, even though I didn't have to do it since my art assets are already correct final sizes. There is no need for resizing them with code. Custom update method. I create a property I call speed and I set it to 20. Horizontal coordinate of the background will be -=20 pixels per frame. This will make it scroll to the left. Inside animation loop, I call background update and it just scrolls off screen. In update method, I create a reset check. I say if this.x is less than 0 minus this.width from line 87, meaning if background scrolled all the way off screen, set its horizontal x position back to 0. To create an illusion of endlessly scrolling background, we need to use a trick here. I will be drawing the same image twice. I will position the second image to the right next to the first one by setting its horizontal x-coordinate to this.x plus this.width. Now it looks like it's just one single endless seamless image. If I put a gap of 50 pixels, you will see where the first image ends and the second image starts. I remove the gap. We never actually see the full size of the second image. They are both scrolling at the same speed, and when we get to this point, the image on the right just fills the gap before the first image can reset and start scrolling again. This happens very fast, so it creates an illusion of endlessly scrolling seamless image. I go much deeper on this topic in a special episode. For now, this is all we need to know here. Sometimes you can still see a small gap where the first image ends and the second one begins. You can easily fix it by accounting for scrolling speed when setting horizontal position of the second image. I will comment out line 120 for now, so the movement doesn't distract us. You can do the same or keep it going, it's up to you. In our game, player needs to avoid dangerous enemies by jumping over them. Enemy class will serve as a blueprint to create a single enemy object. Constructor will expect game width and game height as arguments, because enemies need to be aware of game area boundaries. I check my sprite sheet and width of single frame is 160 pixels. Height is 119 pixels. This dot image will point towards image element with an ID of enemy image. Draw method will expect context as an argument. We call built-in draw image method. I pass it this dot image from line 107. I will also need this dot x and this dot y properties on my enemy. I pass them to draw method here. I create an instance of enemy class using the new keyword. I pass it canvas width and canvas height. I call enemy1 draw from inside animation loop and I pass it ctx. Now we can see what we are doing, so back inside the draw image method on enemy class, I pass it width and height. I also need to pass it source x, source y, source width and source height like we did with player, because we want to crop out single frame from the sprite sheet. Source x will be number 0 times this.width. Source y could be 0 times this.height, but since this sprite sheet has only one row, there will be no vertical navigation, so source y value can stay hard-coded to 0. I create frame x for horizontal navigation in sprite sheet and I replace it here inside the draw image method. Vertical coordinate of the enemy will be game height minus height of the enemy. And horizontal position is game width, so that it's hidden just behind the right edge of canvas. I create an update method and inside we will just decrease x by 1 per frame to make enemy move to the left. I call enemy1 update from inside animation loop and we are animating one enemy created with our enemy class. I don't want to just have one enemy, I want to have multiple active enemies on the screen at the same time. Up here on line 6 I create a let variable I call for example enemies and I set it to an empty array. I delete these two lines of code from inside animation loop. We will draw and update our enemies from inside handle enemies function on line 121. Handle enemies function will also be periodically adding new enemies to the game, so I take enemies array from line 6 and I call push on it. We will push instance of enemy class, so new enemy like this. I know I have to pass it game width and game height, so I pass it canvas width and canvas height here. Then I want to call draw method and update method from line 116 for each enemy object in the array, so enemies for each. I call individual object in that array, for example enemy, and I use arrow function syntax here. For each enemy object inside enemies array, call their draw method. I pass it ctx and also call their update method. I will be calling handle enemies function for every animation frame, so I can't just leave this line of code here like this. I don't want to push 60 enemies per second into our game. I take this line outside temporarily, so it will just run once on the initial page load. So it will add just one enemy to the array at first. I call handle enemies from inside animation loop here on line 143. Perfect. Everything still works. Let's say I want to add new enemy into the array every 2 seconds. How do I do that? We can use timestamps and delta time. I create a helper variable called last time, which will hold the value of timestamp from the previous animation frame. Inside animation loop, I create a constant called delta time. Delta time is the difference in milliseconds between timestamp from this loop and timestamp from the previous loop. The value of delta time tells us how many milliseconds our computer needs to serve one animation frame. Usually if we are running at 60 frames per second, delta time is around 16 milliseconds. So delta time is timestamp from this loop minus timestamp from the previous loop. This timestamp value is auto-generated here. Request animation frame has a special feature. It automatically generates a timestamp and passes it as an argument to the function it calls. So because animate is being called over and over by request animation frame here, it receives timestamp values as argument each time it's called. The first initial call of animate here on line 149 doesn't have auto-generated timestamp because it's not being called by request animation frame, so I have to pass it something here. I pass it 0. When I calculated delta time, difference in milliseconds between timestamp from this loop and timestamp from the previous loop, I set last time to timestamp so that it can be used in the next loop as the value for timestamp from the previous loop. Our animation loop is created by request animation frame. It automatically adjusts the screen refresh rate, so most screens will run at 60 frames per second, which means if I console log delta time, I should get 1000 milliseconds divided by 60 frames per second. My delta time should be around 16.6 milliseconds. If you get a different number here, let me know. I wonder if we all get the same value. Now that we have delta time, we can use it to time different things around our code base. We will use it to trigger periodic events. I pass delta time to handle enemies. I comment this out. I make sure handle enemies expects delta time value. To time something periodically with delta time, I need two helper variables. Enemy timer, which will be counting milliseconds from 0 to a certain limit, and every time it reaches that limit, it will trigger something and reset itself back to 0. We will need enemy interval, which will be a value in milliseconds for that time limit. I want to add new enemy in the game every 1000 milliseconds. Every time timer reaches 1000. In handle enemies, I say if enemy timer from line 140 is more than enemy interval from line 141, push new enemy into enemies array. Then reset enemy timer back to 0 so we can count again. Else, just keep adding delta time to our enemy timer until the limit defined in enemy interval is reached. Using delta time like this will make sure our events are timed the same on slow and fast computers, because faster computer will have lower delta time, so it will take more loops to accumulate enough in its timer. That way, fast and slow computer will reach the limit at the same time. I explain this in more detail in a special class. I can also set enemy interval to 2000 milliseconds, 2 seconds. I create this.speed property on enemy class. I could give each enemy randomized speed here using math.random. I will give all of them the same speed of 8, and here I say this.x minus equals this.speed. You can see enemies come in a set interval of 2 seconds, very predictable. Maybe I want to randomize that interval a little bit. I can, for example, create a variable called a random enemy interval, and I set it to a random number between 500 and 1500 milliseconds. I change enemy interval to 1000. Whenever enemy timer reaches enemy interval plus random enemy interval, I push new enemy and I set random enemy interval from line 147 to a different value. I could have also randomly set some enemies further along x-axis to get the same result. Now enemies are coming in more random, less predictable intervals. Inside the draw method on player class, I can remove the white rectangle behind the player. I pause the background again by commenting out line 154. We are displaying just the first frame in player and enemy sprite sheets. Let's actually animate those sprite frames. The sprite sheets we are using are optimized for speed between 15 to 20 frames per second, so I would like to be able to set FPS, frames per second, for sprite frame animation, while still allowing the rest of our game, things like player position and background scrolling, to update 60 times per second. How do we do it? With delta time. I'm passing delta time to handle enemies here on line 157. I pass it along to enemy update method, and I make sure update method on enemy class expects that value. Update method is being called from inside animate 60 times per second. Inside update method here, I will use the delta time to keep track of how many milliseconds passed between individual calls, and only when the right threshold is reached, I will swap frames in the sprite sheet. To animate sprite sheets horizontally, I will cycle between frame x of 0 and max frame, which in case of enemy sprite sheet is 5. To time frame rate with delta time, I will need 3 helper properties. This.fps to set frames per second, let's do 20. Keep in mind this FPS will affect horizontal navigation within enemy sprite sheet, how fast we swap between individual animation frames, nothing else will be affected. I want the rest of the game to run at 60 frames per second. I could use this technique to slow the entire game down to 20 frames per second, but then player controls wouldn't feel very responsive, we would get delays in collision detection, displayed text and so on. I want to slow down only animation of enemy sprite sheet, nothing else. I will also need frame timer, which will count from 0 to frame interval over and over, and frame interval will define that value we are counting towards. It's a value of how many milliseconds each frame lasts, so 1000 milliseconds divided by 20 frames per second in this case. First, let's cycle between frames at full speed, so if this.framex from line 111 is more than max frame, set frame x back to 0, else increase frame x by 1. I have to do more or equal here so we don't get empty frame. Because of this source x attribute we are passing to draw image method on line 119, cycling between 0 and 5 with frame x variable will animate sprite sheet horizontally. Now you can see enemy sprite sheet is animating, but it's very fast. These particular sprite sheets were designed for lower frame rate. We defined FPS of 20 on line 113. Here I say if this.frame timer from line 114 is more than frame interval from line 115, only then run this code that manages frame x cycles. At the same time, reset frame timer back to 0 so it can count again. Else, just keep adding delta time to frame timer until the threshold of milliseconds defined in frame interval is reached. Now you can see enemy sprite sheet is swapping between frames slower at 20 frames per second, while enemy movement is still at original 60 frames per second. Inside update method on player class, I will do exactly the same thing. First I say if frame x from line 40 is more than max frame, which I need to define here, we will start with this row, and there we have 8 horizontal frames, counting from 0. If frame x is more or equal to max frame, set frame x back to 0. Else, increase frame x by 1. Running animation on player is animating. I go down here to enemy class and I copy FPS, frame timer and frame interval properties, and I paste them here on our player class. Inside update method here we are dealing with sprite animation. Here are controls. Yes, so if frame timer from line 44 is more than frame interval, run all this sprite animation code and reset frame timer back to 0. Else, keep increasing frame timer by delta time. Update method doesn't have access to delta time, so I make sure it takes it as an argument when we call it here on line 181. Up here, I make sure update method expects that argument. Now, player sprite sheet is animating at 20 frames per second. When I jump, we get blinking because max frame is set to 8 on line 41 and jump row doesn't have that many frames, so we are including empty frames. We have only 2 player states basically, jumping and running on ground, so dealing with that is easy. Down here we deal with vertical movement. When we are not on ground, we set max frame to 5 for jumping animation. Else, meaning we are on ground, set max frame to 8 for running animation. On line 151 we are adding new enemy to our game in a randomized interval. When I console log enemies array, I can see it's endlessly growing and adding more and more enemies. I actually want to remove enemies that moved off screen from enemies array. On enemy class, I create a property I call marked for deletion and I initially set it to false. In update method, I say if horizontal x coordinate on enemy is less than 0 minus enemy width, meaning if it has moved past the left edge of game area, set marked for deletion to true. Inside handle enemies, I say take enemies array, which we defined earlier as a let variable, and reassign it to the same array, but filter that array first and only include elements that have marked for deletion property set to false. Filter is a built-in array method which creates a new array with all elements that pass the test implemented by the provided function. In our case, all our elements are tested and checked if their marked for deletion property is false. Now you can see in console we have between 1 and 2 enemies in the array at any given time. Older enemies are being removed. I want to display score. On line 7, I define a let variable called score and I initially set it to 0. On line 168, we have display status text function. I will use it to display current score. I pass it context as an argument to specify which canvas we want to draw on. I set fill style to black color. I set canvas font to 40 pixels Helvetica. Fill text built-in canvas method will actually draw the text. It expects text we want to draw and X and Y where to draw it. I want the text to say score :space plus value of score variable from line 7, X coordinate 20, Y coordinate 50. I call this new function from inside animation loop and I pass it ctx. Inside update method on enemy class, I will count score every time enemy moves off screen, assuming player successfully avoided colliding with that enemy. And I increment score by 1. That works, nice. I want to highlight the font. I can give it canvas shadow, but for some reason in Firefox, built-in canvas shadow property causes lag and frame rate drops, so I will do a trick here. I will draw the same message twice, one black, one white. The top one will have 2 pixels offset, so I kinda created my own shadow manually. Let's check for collisions between player and enemies. First, we need to decide on the right technique to use here. The easiest ones are collision between rectangles and collision between circles, where we give elements like player and enemy hitboxes, shaped as rectangles or circles. We could also do more complex and more precise collision checks here, such as collision check between polygons, called separating axis theorem, or we can base collisions on color or opacity. I will stroke rectangle around our enemies so we can see basic collision hitbox. Let's make it white. I do the same for player. You can see the rectangles now. If I use collision detection between rectangles and I keep those hitboxes at their base sizes, whenever these two rectangles touch or intersect, we will get collision between player and enemy. I tried to apply it before and I played with it, and sometimes we get really unfortunate collisions, like on this screenshot where my player is landing from a jump. Dog and worm images are clearly far away from each other, but you can see that the corners intersect and we got game over. I asked you in my community tab how you would approach this challenge. We spoke about the different options we have here. Some of you suggested separating axis theorem for collision between polygons. Some of you think that we could use a set of smaller rectangles that match shapes of player and enemy sprites more closely than one larger shape. Some of you think that simple collision detection between circles would be enough in this scenario. Let's try to draw circular hitboxes around our objects to see what it would look like. It's also easy to offset these circles by a specific pixel value horizontally or vertically in relation to player and enemy object. We can also make them smaller or larger if needed. I agree with you, and I think that using circular collision detection for jumping game like this will get rid of accidental collisions where two corners of rectangles collide. Now I need to decide where in our codebase we will run collision checks. I know I need to check position of player against position of all active enemies for each animation frame, so I might as well do it inside player update method. I pass it enemies array as an argument. It contains all currently active enemy objects. On line 59, inside update method on player class, I make sure update method expects that argument. We will calculate collision detection here. We need to run it against every enemy object in enemies array, so enemies we passed as an argument for each, and then I do collision detection calculation between player circle hitbox and enemy circle hitbox. To do that, we need to calculate the distance between the center points of these two circles, and we compare that distance with the radius of circle 1 and radius of circle 2. If the distance is less than these two radii added together, we know we have a collision. To get distance between 2 points, 2 center points, we use Pythagoras theorem formula. We have a center point of player circle and center point of enemy circle. We calculate distance on horizontal x-axis, dx. We calculate distance on vertical y-axis, dy. It gives us imaginary right triangle, and we know hypotenuse of this triangle is the distance between these 2 points. We calculate it as square root of dx squared plus dy squared. If distance between center point of player circle and center point of enemy circle is less than radius of enemy circle plus radius of player circle, we have collision and we set game over to true. Up on line 8, I create a let variable called game over and I set it to false at first. I want the game to pause when game over is true, so inside animation loop I say only run request animation frame and continue animating our game if game over is false. You can see that when collision is detected, game stops. Perfect. I also want to display game over message, so inside the display status text function I say if game over is true, set text align to center, fill style to black, fill text, game over, try again, and coordinates canvas width divided by 2 and 50, 200. Make a copy again, set fill style to white and offset the second line by 2 pixels. I need to fix our collision detection. We are using enemy X and enemy Y coordinates as center points of collision circle, which means collision area on each enemy is this blue circle. And same with the player. Since player X and player Y is the top left corner of rectangular area from which player image is drawn, I can't set it as center point of collision circle. Because I did do that, we are not checking for collisions between white circles. We are actually checking for collisions between the blue circles I just drew. The fix is simple. dx, distance on the horizontal x-axis between 2 center points, needs to be offset by half of enemy width and half of player width to move these center points from top left corner to the middle of rectangular area. Same goes for vertical dy check. Brackets are very important here. Now after this fix, collisions are correctly being detected between white circular areas around player and enemies. I can offset these circles by a specific amount to move them around. I can make them smaller or larger. We will expand on this in the next episode. In this class, we will learn how to use native JavaScript full screen functionality, how to add touch support to our games, and how to measure length and direction of swipes so that we can attach specific events to them. Full series linked in the video description. Let's make a mobile game with HTML, CSS, and JavaScript. Let's go! This is the game we built in the previous lesson. I will be using Google Chrome browser as usual, and if I right-click to inspect the page, we have this small mobile device icon here. This tool is great for designing responsive websites. Keep in mind, this is just an estimate. There might be some differences when you run the same code on the actual device. This simulator is not 100% accurate. As you can see, Canvas doesn't even fit mobile screen on landscape. Currently, this project is not mobile friendly at all. It's actually very easy to fix this. I can click this icon to toggle between landscape and portrait view. I can choose different devices from this drop-down. So the first thing I want to do is to make sure we can see the entire canvas at all times on mobile. I will do it with CSS. I give canvas max width property of 100%. We are missing left border here. Let's reset all default margins and paddings and set box sizing to border box to make sure element's border is included in its total width. Modern CSS makes life so much easier. So now in portrait mode you can set canvas to any width and it will always scale up or down to make sure we can see all of it. I switch to landscape and we have the same problem. How do we solve this? This is actually also very easy, barely an inconvenience. I give canvas max height 100%. Now canvas will scale until it hits edges of screen vertically or horizontally, depending on aspect ratio, whichever boundary it hits first. Look what happens when I make canvas wider. It still works. I can switch devices, toggle between landscape and portrait. We can see all of canvas at all times. Perfect. There is also a way to make canvas fit the entire screen with no black edges, but because of the scrolling background we're using here, I would have to calculate aspect ratio. I want to keep this class beginner friendly with no algorithms, so I will get back to that in more advanced tutorial. Now you know a quick and easy way to make canvas fit on mobile screen without stretching and distortion. The only way to restart game right now is to refresh browser window. Let's write an actual restart game function so that we can connect it to buttons or key presses or touch events. We have to think what needs to happen when game restarts. Well, first we need to restart the player to its initial position. I will actually do it as a method on player class. I will call it restart, and inside we set x and y to the original values. Let's move player 100 pixels to the right, here and here. That's better. After restart, I want player in running animation, so max frame will be 8 and frame Y is 0. Down on line 200, inside our custom restart game function, I take instance of player class from line 205 and I call restart method we just wrote. I don't really have to restart background, or maybe I will just restart its X position back to 0 so that we get some more visual feedback that we are actually starting a new game. Again, I take an instance of background class from line 210 and I call restart method we just wrote. The last thing I need to do when game restarts is to take enemies array, score and game over and set them back to their initial values. Notice I'm removing let keywords because I'm not declaring new variables, I'm just assigning new values to existing variables. Where do we call this restart game function from? Here inside event listener, inside key down event, we listen for arrows and we push them into this .keys array. I will create an else statement, and if key that was pressed is enter, and at the same time game over from line 8 is true, we call the new restart game function we just wrote. It's still not working, and it's because when game over is true, I stop calling request animation frame here. Since we are setting game over back to its initial false value, I can call animate again to start new animation loop, like this. So we are playing, game is running, I get game over, I press enter and reset function resets our game. Awesome, we are doing great so far. I should tell the user to press enter, otherwise how would they know? You can see after game reset, score is off screen. It's because it's taking this text align center we used for game over message. I need to set text align to left here. And the message will be something like game over, press enter to restart. This works. Okay, touch events, this will be fun. First, I remove this console log from line 175. Up here inside input handler class, we will create a new event listener for touch start event. It will run whenever user touches browser window. When that happens, I console log something. I will actually also need touch move and touch end events. I'm gonna console log start in touch start, move in touch move, and end in touch end. The way these work, touch start fires once as we start interacting with screen. Then touch move fires over and over as long as we are moving finger over the screen, and touch end just fires once when user releases the touch. This is important to remember as we have to consider these when we are structuring our code. Code in touch start and touch end will run once, and the code in touch move will run over and over as long as the event is firing. This is actually very useful, and we can use touch start to set something up, touch move to make a calculation such as direction and time of the event, and in touch end we do some cleanup and discard or reset values we don't need anymore. There is no swipe up and swipe down event, so let me show you how you can easily use these three touch events combined to determine direction of swipe. Let's have a look at auto-generated touch start event object by console login E. When I touch screen, this event fires and I can inspect it. There are many useful values here. For example, it keeps track whether Alt and Control keys were pressed at the time of the event. We have timestamp of the touch here, very useful, and the main thing we care about is X and Y coordinates of the touch. X and Y coordinates of touch event are stored inside this read-only changed touches property. It's a list that stores auto-generated touch objects that contributed to this touch event. With touch start event, we get just one object, so we have to open index 0, and here we can see page X and page Y properties. Perfect, we know where on screen this touch event started. If I console log touch move and I swipe across my screen, you can see that event fires many times. Let's go to one of the ones at the start. If I check inside change touches list at index 0, I can see page Y is 71. As I was swiping, the event was firing, so let's go to the last time it fired, and here I see page Y is 104. I know this particular swipe went vertically from coordinate 71 to coordinate 104. We have all these values we need to determine whether user swiped up or down. I put this console log into touch start event and I remove all other console logs. To access vertical coordinate of touch event, I say e.changedTouches, index 0 because this is a list, and I want this page Y property. Okay, let's put that inside touch move and touch end. I create a new property on input handler class. I call it, for example, touch Y. It will store the initial starting vertical coordinate. Maybe I also want the game to only react to longer swipes, to make sure user actually swipes and the game doesn't accidentally react to simple short taps. I will call this property touch threshold and I set it, for example, to 30. I want the starting touch point and the ending touch point to be at least 30 pixels apart to trigger the event. I could also make the player jump higher here based on how long the swipe is. This technique is easy and very powerful if you are designing mobile games. I hope you are realizing the potential here. In touch start event, I just want to set starting coordinate, so this.touchY from line 13 is equal to page Y value from this event. Let's delete all these. Inside touch move, I will compare current coordinate and starting coordinate to determine direction. So let's have a temporary helper variable called, for example, swipe distance and set it to page Y value of this tick of touch move event minus the initial starting vertical coordinate. So minus this.touchY from line 13. Keep in mind that touch move fires over and over again as long as user is swiping. I need more space here. If swipe distance is less than minus this.touch threshold from line 14, so minus 30, we are swiping up, so this.keys push swipe up. This might be a little bit difficult to visualize for some of us, so here's some animation if it helps. At the same time, I want to check if swipe up is not yet in the keys array. So this is the distance between current vertical coordinate and starting Y coordinate. If this swipe distance is less than minus 30 and swipe up is not yet in keys array, push swipe up into keys array. Else, if swipe distance is more than this.touch threshold, so plus 30, push swipe down into this.keys array. Also here I need to check that swipe down is not yet in the array before I push it in there. I don't want duplicates of the same value. In touch end, I just console log this.keys. I can see we are getting many duplicates in the array, so something must be wrong here. I zoom out a bit so I can see the whole thing on a single line. These brackets need to be here. Brackets are important, it's easy to make a mistake and even a small thing can break the entire project. That's programmer's life. Attention to detail and debugging. Perfect, now it gets added only once per value. As I said, I will use touch end event for cleanup. I will use splice method to find swipe up in keys array and remove it. And I do the same thing for swipe down. So in touch start, I save initial vertical coordinate of touch event. In touch move, I compare starting vertical coordinate to the current vertical coordinate to determine whether user is swiping up or down. And in touch end, I clean up and remove all touch events from our custom keys array. Let's remove this console log. I want to restart game when we swipe down. I might as well put it in here, why not? So if we swipe down, call our custom restart game function we wrote earlier, but only do it if game over is true, like this. So I get game over, I'm swiping up, nothing happens, I swipe down and game restarts, great. I can increase touch threshold if I want some functionality to work only with very long swipes. I set it to 200, I swipe down but only short, nothing happens. Longer swipe, still nothing. I have to swipe almost the entire screen from top to bottom to restart game now. So let's put the threshold back to 30. I want player to jump when we swipe up, so here inside update method on player class I put this part in brackets because I want it to evaluate first. If keys array contains arrow up or if it contains swipe up and at the same time if player is on ground, make player jump. Be careful about brackets, it's easy to create a bug here if you forget one. Let's see, reload game, I run, swipe up and player jumps. I swipe again and again. This works! Touch events work really well with simple games like this. In the next episode I will create a game with more complex moves and special abilities. Game like that is a bit more complicated when it comes to touch events. Also, in most cases, to make a mobile game like this work, you should resize your art assets. My player sprite sheet has frames 200 × 200 pixels, that's massive for a mobile game, and if I had many animated objects on screen at the same time, it would start lagging very fast. For a bigger game, I would have to create 2 or more sets of art assets for different screen sizes. Let's change game over message so that user knows we can now swipe down to restart. JavaScript also offers built-in native full-screen API that's easy to use. It's now well supported in all modern browsers. As far as I know, only Internet Explorer and mobile version of Safari don't fully support it. We are web developers here, so I'm sure all of you use updated version of a modern, secure browser on your machine. Full-screen API gives us methods that allow us to present a specific element and its descendants in a full-screen mode. It will hide all browser user interface elements, sidebars and other applications as long as full screen is active. Let's create a button to toggle full screen. I give it ID full screen button, for example, and it will say toggle full screen. In CSS, I give it position absolute, font size 20 pixels, padding 10 pixels, top 10 pixels, and transform translate x -50% to center it horizontally. I bring it to my JavaScript project using getElementById. I create a new function I call, for example, toggle full screen. Let's console log document.fullScreenElement like this and call toggle full screen function we just wrote. Full screen element is a built-in read-only property on document object that returns the element that is currently being presented in full screen mode. If it's null, it means the full screen is not active. We can use this property to check if we are currently in full screen mode. I say if full screen mode is not active, take canvas variable from line 2 and call built-in request full screen method. This method is asynchronous. It returns a promise, which means I can chain then and catch methods to run some follow-up code when the promise is fulfilled or rejected. I will just use catch today to display potential error. Notice that the request full screen is called on the element I want to make full screen, but full screen element property sits on the document object. Today, I won't put any follow-up code in then method, so I can delete it. In catch, I will take the auto-generated error object. If error happens, we will create alert, and it will say some error message. To concatenate message, I can use backticks instead of quotes. This is so-called template literal syntax. It's just a simple way to combine strings of text and expressions that need to be evaluated into a single final line of text. I say, for example, error can't enable full screen mode. And to insert variable or expression inside template string, we use $sign and brackets like this. Here I just put this auto-generated error object and its message property so we can read what went wrong. So if full screen is currently not active, present canvas in full screen mode. Else, meaning full screen is active, call built-in exit full screen method to switch back to windowed mode. Notice that exit full screen is again called from document object. If I save my project and refresh browser window, I get an error. You can see catch method worked and created alert pop-up window with our message. In console, I can see more information. It says full screen can only be initiated by user gesture. Here I declared my toggle full screen function, and here I'm calling it on the first page load. We can't do that. Full screen can only be triggered by user-generated events, such as click or touch. That's what this error message is telling us. We can't just make JavaScript to automatically trigger full screen. It needs to be triggered by a user-generated event. So instead of running it on the first page load, I create an event listener for click event on full screen button element we created earlier. When user clicks button, then run toggle full screen. To exit full screen on a computer, you can also just press escape key. On mobile, you can exit full screen by swiping to reveal main controls and press back or home key depending on which phone you are using. Sometimes we get unexpected collisions and game over when player and enemy images are not actually touching, like this. It's because we are checking for collision detection on circular hitboxes around player and enemy, and these circles don't exactly match the sprite sheet image. Collisions between complex shape take a lot of performance, and especially for mobile games, performance is something we need to be more careful about. Phones don't have as much computing power as our desktop computers do. It's usually not a problem when hitbox doesn't exactly match sprite-sheet shape, but it should be positioned in a way that it's predictable when collision can and cannot happen. I drew a simple circle around player, and now we can see its collision area. Let's copy this code to display collision area of enemies as well. You can see, when these two white circles touch, we get collision, and since the circles are larger than player and enemy image, sometimes we get collision when player and enemy images are clearly not touching, especially this one, when we are about to land from what seems to be a successful jump. How do we fix this? Since player and enemy images are not scalable in this game, they are drawn at fixed width and height, we can shrink and scale hitboxes by a value relative to image size, and we can also move the hitbox left and right by specific pixel amounts to try and match images more closely and make collisions more predictable. We don't want surprise game over like this. I'm using a bit unconventional technique here because sprites are in a sense rectangular. They have starting X and Y position and width and height. But I chose collision detection between circles to remove rectangular edges from sticking out outside player and enemy shapes. What I'm about to do will work with rectangular collisions as well, if you prefer that. We are calculating collision detection between player and all active enemies here. I explained it in the previous episode. We are basically checking distance between center point of player circle and center point of enemy circle, first horizontally and then vertically. We are drawing imaginary right triangle and using Pythagoras theorem to calculate the length of hypotenuse, which is basically the distance between center point of player circle and center point of enemy circle. Then we are comparing radius of player circle plus radius of enemy circle to that distance. If distance is more than sum of these two radii, circles are far apart. If it's the same, circles are touching, and if the distance is less than sum of radii, circles are overlapping. Here I'm just drawing white collision area circle. It's just a visual, it doesn't actually detect collision. Collision is being detected here. We are inside player class, and this is the horizontal center point position of player circle. This is being used for collision detection here. This is vertical coordinate of that center point, which is being used in collision detection formula here. And this is the radius of collision area circle we are drawing, and that same value is being used in collision detection formula here. I can simply offset and resize that collision circle visual in this area, and then replicate those changes inside the actual collision detection calculation area here. Let me show you what I mean. What if I want player circle to be smaller? Maybe I don't mind that ears and tail overlap. Let's say they are soft and they don't count when it comes to collision. Also, maybe I want to make my game a bit easier and forgiving. This will allow a small overlap between player and enemy image. What if I want to move the collision hitbox downwards relative to player image? I change its vertical center point position here, plus 20 pixels seems fine. Now I compare changes I made to the visualization, and I make sure I update the actual collision detection formula to match these new values. I didn't make any changes to horizontal center point, so that value stays the same. I added plus 20 pixels to vertical center point, so I update it in collision calculation here. I also made the circle smaller, so I update player radius value in this area. We successfully adjusted player hitbox. Let's also do something about enemies. I can, for example, reduce the radius of enemy circle. I also want to move it to the left to cover head of the worm better. Maybe minus 20 pixels for a horizontal center point. I'm actually happy with this. I want collision to only happen when these two adjusted smaller circles collide. Let's take the changed values we used to adjust enemy hitbox visual and transfer them into collision detection formula, like we did with player. I copy this line just so I can look at it for reference. I put it here just temporarily. Collision detection is inside player class, so this keyword here points to player object. If I want to point towards enemy object, I can't use this keyword in this area. We adjusted horizontal coordinate of enemy circle center point, so I need to adjust it here, minus 20. Vertical center point of enemy stayed the same, so I will not be making any changes here. We did change enemy radius, so I will change enemy radius here. And this is how you resize, scale and reposition hitboxes in your game to make sure they match your art assets more closely. I didn't plan to make this episode, but so many of you asked how to add mobile support to our games, so here we go. We can take it much further, but I think this was a good beginner-friendly introduction. Check out full series in the video description if you want. I'll see you there. When your games and applications start getting bigger, more exciting and full of extra features, it will be more and more challenging to keep your code clean and organized. Over time, people came up with the general, reusable solutions to commonly occurring problems. These well-tested and widely used code structures are called design patterns. Design patterns are a toolkit of tried and tested solutions to common problems in software design. You could split design patterns into three main categories. In this class, we will use state design pattern to control player character in a game. It's a behavioral pattern that lets an object alter its behavior when its internal state changes. Why do we need to manage player state? Let's say we have a simple side-scroller game. Our character is standing, and when I press up arrow key, I want it to jump. This code has a bug. If I keep pressing up arrow while jumping, player character will fly off screen. So I have to do a check here. Only run this code and jump if character is standing on solid ground. Great, that fixed it. I also want to add sit-in animation, but player can't enter sit-in state while it's in the middle of jump. Player can sit down only when it's standing or running on solid ground. Maybe I also want a dive attack when player tackles enemies from the air. Again, this move can only be entered by pressing down arrow key while jumping, because when we are standing, down arrow key will make players sit down. I'm sure you can imagine how adding more moves will create a very complicated if-else statement, and since all of that is contained in a single piece of logic, adding one new move later on can break all your other existing conditions, and you will have to review that single massive logic tree every time you need to fix a bug or add a new feature. Since this is a very common challenge game designers had to deal with for a long time, there is a tried and tested way to do this right. What if instead of this complicated spaghetti code if-else statement, we model our code structure based on finite state machine? We want to have a limited set of states player object can be in, such as standing, jumping or sitting. Player object can only be in one of those states at a time, and for each state, it will only react to a limited set of inputs we define. That way, we have a class for each state, and in rules of that class, I can say that while player is jumping, wait for a certain time before switching it to falling state, or if you detect down arrow key input, transition player into diving state. Other than that, while in jumping state, ignore all other inputs. So pressing down arrow key while jumping will switch player into diving state. Pressing down arrow key while standing will transition player into sitting state. In this class, we will learn how to implement state design pattern in a side-scroller game. We will learn how to use the native JavaScript modules to split our code into multiple parts, and many other important game development tricks and techniques as usual. Click like if you are ready to start building bigger games and learn how to make our code bases scalable, easy to navigate in, easy to manage and debug. We are diving into more advanced territory today. The challenge for beginners will mostly be to keep track of what each class and function is doing and how they interact with each other. Check out some beginner-friendly game development tutorials in the video description if you just recently started with HTML, CSS and JavaScript. I created a simple web page. This doc image will be our sprite sheet. You can download it in the video description. It was made by this amazing artist. Check out his site for more game development art assets. I include my image as img tag this time. That way I can wait for the image to get fully loaded before I run any JavaScript. I include my JavaScript by using a script tag, but this time I will set its type attribute to module, like this. This will cause the browser to process any contents of this particular script as JavaScript module, which will allow us to split our code into multiple separate files and use import-export keywords to connect the data inside. You can see I'm importing only the main script.js file, but we will also have player.js, state.js, input.js and utilities.js. Splitting files like this makes our project a bit cleaner and easier to navigate in. JavaScript modules allow us to split our programs into separate parts that can be imported where they are needed. Node.js had this ability for a long time, but now modern browsers support module functionality natively. Use of native JavaScript modules is dependent on the import-export statements, and we will cover how to use them today. It's easy, don't worry. There is only one catch when using modules. You need to run the code in some kind of dev environment. You need to have a server. If you just write index.html file and click to open it in browser locally, as you can do with all my other course projects, import-export keywords will not work. You need to run this code through a server. There are many ways to set up a local server. The easiest one is to install a small plugin to your code editor. I'm using Visual Studio Code, and when I click here on the left side on the extensions icon and I search extensions for live server, I find this plugin. It's been downloaded over 17 million times, so it's very popular. Mine is already installed, but if you don't have it, it will say install here. After installation, you might have to close or reopen your VS Code. When it's successfully installed, you will see this Go Live icon right here. If you never used it, it can act a bit unexpectedly. When you click Go Live, it doesn't open the file you are looking at the moment. It will run code from the entire project folder your VS Code is currently pointed at. To make sure your live server goes live with the correct set of files, you click File in the top left corner and then click Open Folder, and you navigate to your project folder on your local computer. When you find it, click Select Folder, and then when you go live, the correct project will open. If you can't see this new live server notification area, close your VS Code completely and reopen it, and it will get loaded. The best thing about Live Server extension is that when you save any of the project files, it will reload browser window automatically. You can always see the latest preview of your code without constantly manually reloading browser. On my Windows computer, I use Ctrl+S keyboard shortcut to save changes to my file. I use it a lot while working in this environment. So now we should have a project folder running through Live Server extension. We have index.html file, style CSS, main script.js file. We will have player.js, where we write all the logic to control and animate our player character. State.js will be where we write state design pattern to swap between different player states. Input.js will handle keyboard input, and Utilities.js will have small useful functions that, for example, display status text or some other small tasks. I will speed up CSS setup because that's very basic. Global reset to make sure the page looks the same across different browsers. I will give Canvas some background so we can see it, and I will hide the sprite sheet image, since we will be drawing and animating it with JavaScript. I will also show you how to create a very simple loading screen. I wrote this h1 tag with an ID of loading, so I grab it here, I center it in the middle of the page, and I adjust its font size. Script.js is my main module, which will connect